Hello people, let's fucking go. Sarun, you're so fast. I just sent the message on my Discord. Let me get my water. I already have it. Not yours, but mine. Okay, so that was fast. Okay, glad to see you, man. So, hello. Oh, Kitty Pulse, welcome. Well, welcome here, welcome back. And yeah, that's a shame about your pizza, man. Let me show you this. So, yeah, basically, Kitty Pulse tried to get a pizza for a birthday party, I think. And the pizza was wrong. like two slices were like correct, but the rest wasn't at all. That's like such a shame. Like, how is it even possible? Like, they just decided to take a pizza and cut two slices and put like 2 slices of what you wanted. That's why I saw like a game on someone's stream, like you have your own fish and you can feed it, hunt others using Twitch live chats. Oh, I mean, I saw a few other games on Twitch. I really wanted to make something like that at some point. Some kind of, you know, trying to gamify the stream a little. But then I got, you know, motivation. I decided to do my Minecraft thing. The streamer is Kinds in Shifts. Check it out, bro. That shit is so cool. Okay. I'm gonna note it somewhere and maybe even raid him after the stream at the end. Oh, W. The 5 stream streak. Incredible. I actually just realized why I was drinking so little, but still drinking a little. I think it's because with my throat, I want to keep my throat hydrated. And yeah, to show the games, so we have grass biomes, we have snow biomes, we have some caves, of course, like there. But last time we decided to... Well, we also have collisions, right? Like if I go down, we... What the fuck is that? Wait, what? I have some kind of problem. Oh. It's looping forever. Is that it? Yeah, it is. Okay, so we have a problem. We have a problem. That's interesting. I didn't have that last time. Did I push everything? Let me take a look at what I have. No, I have a lot of modifications I haven't pushed. I'm just gonna look at this. So this is valid. So when we go there, we get the neighbor, and this is now. So yeah, okay. Yeah, it's up there. I got 1.7k points. Oh, that's a lot. I should definitely work a bit on like the stream, like add some nice stuff, and you know. It's like more time. I don't have time. I feel like this game is gonna take so much time in the first place that time. If only I could exchange channel points for time. But yes, the neighbor is not set correctly, which is a bit weird. So we have the node. Last on the process, we have the neighbor index too. So we go in. We try to add a new node from coordinates. Just use one of those straw glasses type of things to sip your water instead of grabbing your glass every time. Maybe I should. Find or create. Okay, let me Is it? Wait, is it supposed to exist? Data to node. What are the coordinates? 2 minus 1. Wait, 2 minus 1. Let me take this. Element. Key. Wait, I only have this. No, it's a pointer, right? Yeah, what? The size is so big. You had dinner, by the way? Yeah, I did. I suppose it's around 9 PM there. Yeah. It is 9 PM. I don't know what I did today. I don't know why I'm streaming so late. I don't know what's happening. I'm just really tired. Overall. I'm probably not gonna... Like, maybe tomorrow or the day after. I'm not sure I'm gonna stream. I do have some things to do too. After work. So I'm gonna see if I have the time or not. But, okay, let's say we try to find. Oh, well, find or create. Oh, my bad. Okay, let's register the chunk. Maybe. Okay. So then we go here. We try to find 2 minus 1, 0, which is the current one. And we do find it. Then we try to find the neighbor. Where is the neighbor? Wait a second. That's not... Wait, chunk? We have chunk? Then we have neighbor chunk. Right, so we get the neighbor. Is it good? So we did find the neighbor. We cast, this is correct. And when we try to find it, we find the node, and we set them as neighbors. Oh, I mean, I don't actually need this thing, but okay. So we set those as neighbors. Wait, I don't even know. Wait a second. Chords 0, 0, 0. What's that? Why is that 0, 0, 0? The neighbor of 2 minus 1, 0 is not supposed to be 0, 0, 0. Wait a second. Let me go there again. So I try to find. Anyway, this is 0. Huh? How is that possible? Neighbor chunk. That's weird. Let me loop again. So we have this one. 2 minus 1, 0. And we get the neighbor. How is that possible? Wait, let me loop one more time. Yeah. We go in. We go there. We check if it's valid, so we have this. What? Wait, why are we here? Right. Oh, wait, I skipped it again. Game go bro. Yeah. Wait, let me put another breakpoint there. Okay. So you have 2 minus 1 and 4. I'm gonna go in. Oh! The coordinates are not valid. Oh, but that's kind of stupid, isn't it? That's kind of stupid. Okay, I get it. I get it. Okay, I get it. Shit. Okay, that's stupid. What can I do? I don't like it. It's like for the repeat. I'm just gonna do something simple. I have the tiling type over there. Oh, but it's an override. Why? Maybe I can do that. Drink. Hey, sure. Thank you. Do something like that. And I'm gonna go here. Boom. And I'm just gonna call this. But in here, I'm gonna have a default styling. So chunk, neighbor, index, styling type, clamp, I guess. Okay, and now we can call this one. Nope. So tiling type, repeat. And this one is gonna get... Well, it's gonna call this get neighbor chunk calls, maybe. I think that should be good. I don't think it's a virtual function, so I can modify it however I want. Yep. Oh, I also have the tiling type, right? Oh. Wait. Right. It actually has to be right. I guess technically I can have something like tiling type. Then I can modify this. And instead we're gonna have reference 3, I think. Well, address 3. So address 3. This is an array. And now we need something here. And this something is gonna be tiling types equal this everywhere. Boom. Here we go. Perfect. Okay, so what about now? What about if I... Well, I need the same... Ah! Where is it? Tilings, here we go. So in this case, we're gonna... Wait. We're gonna tile. Except, well, we're gonna repeat. Except here, where we're going to clamp. Clamp, clamp, clamp. And tiling types. Okay, maybe something like that. What about if it goes down to below 0? I'm not sure. But let's say we have this. Okay, so we test if it's valid or not. We also want the tilings though. I'm just gonna remove this. Am I? I mean, no, I actually don't even need that because we have the wrap, the clamp, and the repeat. So I don't even need this in this case for this function. Okay. Okay, should be good. Should be good then. Well, actually, maybe there's going to be a problem below 0. As I said. But well. Yeah. If index is valid, we return as null. Chunk calls to chunk index. Yeah, it's a find, right? So it's just going to return. It's just going to return null, is it? Is it? Final cards. Ah, maybe not. Wrapped cards. Oh, yeah, no, never mind. It's just going to be negative and then it's not going to find. So yeah, it should be good. Now, I hope. We all hope. Boom. And it's looping forever. Hey. But it's not going here though. Huh? Wait, that's... What? What's happening? Let me restart. That was something. I don't really understand what happened. I'm just gonna put a breakpoint there at first. And we're gonna see after that. Is that like a recursion or something? Boom. Okay. So there's a problem. Register chunk is going there though. So it doesn't seem like there's a big loop. Wait, that's weird. Register chunk. It's not recursive. Okay. So it's still here. But for some reason it didn't breakpoint. Oh, it's a visual loader. Oh, it's a visual loader. That's why. Okay, so we try to add the chunk from neighbor. You go here. It gets this, I guess. Why not? I mean, that's not a problem. I mean, I'm not... Everything is supposed to be the same as before. Here. So... we register. Oh, I guess this is a difference though. But aside from that, it's supposed to be fine. Is it just like excessively low? No, it's supposed to be in another thread. Is it? Maybe not. Ah! Multi-threading issues? I don't think so. Yeah, let's go up. So is that valid? This is valid. So we continue. We step. We go in and the neighbor is gonna be null. Yep. Why is it null now? When it was fine before. I haven't changed. What did I just change? I just changed this. Oh, I think I know. So we have this. Try add the chunk from neighbor, right? So for now it's like the same as before. We go here. We have the get neighbor chunk cards. And we have the try add chunk from cards. So let's go in. This one is supposed to be the same. Right? It is. So we have a bunch of things. We modulo, everything is good. 2500. Good. And then we go here. And... Huh? Yeah, it's the same as before. I don't really understand. Multi-thread? No, it's not even a question of threads. I think. We instantiate. We register. I mean, there's still... I guess we still have this, right? Maybe I'm setting things wrong. Okay, let's try to go in. So the current chunk is 2500. Okay, this one is not valid, but one here should be valid, right? Actually, it's not. Nothing is valid. Wait a second. That sounds good. One is supposed to be valid. It's a repeat. I mean, at least one is supposed to be valid. So let's say we have all of this. Invalid coordinates. Is it? Wait, why is it invalid? Wait, why is it invalid? I don't get that. But I mean, if I print everything here all the time, then I mean, it's gonna be very slow. So I'm gonna remove this. Get neighbor chunk cards. Yeah, why would it be invalid? Let me just keep it for now, I guess. Okay. Huh? Repeat, can't repeat. Okay, so we have 2400, and this is supposed to be alright. This looks good. Okay, I think I'm just gonna remove this and retry. Oops, I never bet. Boom. Oh, right, yesterday someone told me about TikTok Live. I'm not really sure about that. TikTok Live, it is good. The stream programming. Yeah. Shorter attention spans. I guess. I think that Streamer Live Studio is garbage. Oh no. Well, I'm not so sure anymore. Okay, let's try to start. And is it gonna work? I mean, no, it wasn't a problem of text. It was a problem of the neighbor being done. And I'm not sure why this is the case. Let me actually remove this. Because that way we should be returning to... Oh, let me actually even remove this. Because now we should go back to how things were before. So the visuals shouldn't have any issue. Because I'm calling the same functions for the visuals as before. So that would be weird. Maybe it was like this chunk set as enables that I was still calling. Maybe this was wrong. I don't know. Okay. And this is still looping forever. So there is a problem in here. What about if I go in? So this is 2500. Is this the problem? I think it might be. Yeah, I changed this. And now I'm calling this that uses a tiling type, which is a different version. So, okay, there is a problem there. Got it? Okay, so let me get this. And I'm just gonna call it the same as before, without the tiling type. And we're gonna go like this, probably. So then I go here. Wait, I actually don't. Wait, what? So this one is gonna get called. And something is different between this and this for some reason. Wrap, clump, repeat. Oh, right. If it's a... Oh, it's supposed to be a wrap. Oh, right. Wait. Wait. So I was doing... I had this, right? And I had a clump. But it wasn't supposed to be a clump. It was supposed to be a wrap, that's why. Let me think. I mean, let me just go there for now, and I'm gonna update this. It's still not working. Wait. Okay, let me try the same as before, but with a wrap. It shouldn't do this. Done. Okay. And we still have the problem. But now we have this. We have -1, 1, 0. And 0. Okay. We can go here. So -1, 1. I do things. And we have from -1 to 24. What? Is it supposed to be 24? Wasn't it supposed to be like 25? Actually, I can just check this. -1, 1. And this is a list of things. 0 is -1. So this is -2 now. But why is the chunk minus... Wait. Why are the coordinates in the first place like this? Collision. Oh, this is because of collisions. Wait, this is because of collision. And we have repeat. Register chunk. That's a pain. But I guess it's supposed to be a problem for collisions now. Wait, but we have the wrap though. It's calling this. Well, we've registered. Well, okay, never mind. Yeah, this one has -1, 1 though. That's crazy. That's not supposed to be the case. Like a chunk is not supposed to have those kind of coordinates. Yeah, I mean, I was wrong, right? I was mixing up different kind of referentials. I was wrong. Try add collision from neighbor. Yeah, I think this function in itself is... I mean, maybe this function is fine, but get neighbor chunk chords. Okay, maybe this one is fine. -1, 1, 0. Because chords is good for this one. We have all of this. Yeah, this seems to be good. But then, inside, we have try add node from chords. And those coordinates are wrong. Those are the node coordinates, not the chunk coordinates. So this is valid, but this is not valid. Osprexan, hey, Axaver. Okay, I could do something very simple about that. And this is, instead of clamp, I want to warp, I guess. So wait, styling. No. Let's have. So this is the node coordinates. And then we have the chunk coordinates. And those are going to be, if it's clumped, then it's equal. And else, well, and else is going to be the equal, basically. No, not equal. It's going to be wrapping. So with a pose mode like this. Yeah. Wait. Oh, right. Like this, and default is... Okay, this is good. Default is this. Boom. And we have this. And this current NB chunks. Wait, what? Post modulo is not working. Right, because we need this too. What is current NB chunks? Get NB chunks. Okay, that was simple. Okay, now here we go. And now we should have the right chunk coordinates, but those are nodes coordinates. So that's the difference. We have to make the distinction between the node coordinates for the collision space that might be negative, etc., and the chunk positions that are always between 0 and the maximum. Okay, but yeah, how are you? What are you up to, Arcsaber? Did you sleep well? Because it's stream time. Wait, what? Skipped. Huh? What? It's skipped by... Huh? Huh? I mean, yeah, I know that. And I guess that was the error. That's fine. I'm actually going to just do this. And that way I can just reuse NB chunks there. I guess that's even better. Boom. Alright, I have to feel some healing for my skull. Compiling. And so what do we have? Collisions. We try to finish collisions to make them loop around. We are trying to make it more clean, a bit cleaner to have graphs. So we have a repeating graph, we have a looping graph, a wrapping graph, and we have the base graph that is normalized, you could say, clumped. Clumped might be the wrong word, but okay, let's go in. It's still looping. I don't know if I'll be able to do that. Collision loader. I mean, it's just for the collision loader now, right? It doesn't seem to be for anything else. So I guess that's a good thing. But I mean, we still have some problems. Oh, and it's looping forever because I commented out this, right? Right. Okay, now it should be good. Please, please. Learned playing alto recorder flute. Oh. And lifting waves while prompting. Ooh. Which is, of course, brilliant. It's brilliant. It's a brilliant move. It turned out that the AI can't model complex decisions, so I need to try to create an arena where it iterates towards a score on its own. Okay. Okay. Like it's battling itself to update the score. I guess you have an evaluation function. Okay, let's continue, please. This time... Okay, no. Maybe not. Okay, if I break again, we have collisions again. And I just want to check the problem again. I want to verify it. So when I go here... Well, I mean, this is fine. But when I go out... Wait, it's looping forever? Register chunk, find neighbor. Wait. Register chunk. No. That's good, right? Wait, what was that? Chunk space. Huh? Okay, let's go out. And we are in register chunk again. I feel like something is wrong. But, let's not think too much about it, I guess. Okay, so we have this. This is valid. We can step. But then we have the neighbor that is null. Yep. So yeah, the goal is to fix this. Again. It's still the same problem as before, but yeah. So... Okay, we go in. Find neighbor chunk. Wrap, clump, right, wrap. Is it? Hey, why is it this one though? Oh, it's a register chunk, right? I mean, registering is fine. But then we have this. So let's go here. And... wait, what? This is now. Oh, this is different. This is different for sure. Interesting. So the coordinates are 25... Oh, because it's looping this time. Oh, right. Yeah. I mean, I guess it's different. But I mean, that makes sense. That's the problem. So maybe... Yeah, the problem is that it makes sense. That makes sense. What if I go there? Oh. And instead... I add this after this register chunk. And I update the neighbors there, maybe? If I add nodes, that would make sense. My god, that's so big, but that's fine. Can remove this. Update neighbors. Update repeating graph neighbors. And we have the the new chunk. It's the new chunk with this. Right. And that should be good. Wait, is it? No, it's not. No, it's not. Because the coordinates are not chunk cores. The coordinates are the node coordinates. I mean, technically we already have this though. Until now I tried to model a good player by algorithms, but it's going nowhere. Yeah. I mean, it can be hard. I know what I did. I know what I did for a few games is like, you know, just like the best. Well, you play the best moves. Basically like chess, right? Like the chess AI is about predicting the best moves and you do things about that, but might be different from what you want from your game. So we have the node coordinates. I mean, we already have the node, as I said. So yeah, we already have the node. I'm gonna remove this. Here we go. Then I try to find the neighbor chunk, so it's repeat. Okay, now it should be alright, I think. Find neighbor chunk. I'm not sure about this function. Once again. But I think it's fine because I actually have no idea. It doesn't seem to be fine. So let's go in. I mean, is it even going? Okay, it is going there. So it is updating this time. So wait, this is updating. Wait, this is crazy. What is the neighbor node? 2410. So it's not that bad, but I think the coordinates are wrong. Like this one is... Yeah, this one is 2410. Wait. The coordinates there are -110. And that means if I want the next coordinates, I want -210, for example. I don't want 2410, which is a problem. So instead I'm gonna go there, because I remember that we have this. And I'm just gonna use that. Tiling type equal let me go in there. Well, it's 25 now, so it's not good anymore. But let's continue. I'm still curious. Repeat its equal. We have the final cards. And am I trying to get... How is it supposed to be good? I mean, I don't even need the tiling type here, I think. I just need to find the chunk, really. And that's fine. Oh, wait, it's about the chunk. Yeah, we don't even have the coordinates, so I mean... Okay, technically maybe we can just do that. And... yeah, what we really want is like the coordinates. We want to change the coordinates. And the coordinates are gonna be... not chords plus this. So we can have something that can be negative. Wait, that's a problem. Is it because of this? Yep. Okay, good. No, because it's a delta. Okay, got it, good. I mean, it shouldn't even be a vector 3, I guess. That's fine. Please, please. Please. Work so that I can clean everything up. I don't want to modify too many things right now, that's a oh! It's compiling. It's running. If I go there, I have a collision. And I'm stuck. Why am I stuck? Because of this. Okay, let me try something else. I'm gonna restart and I'm gonna try to move around this time. Because I think this is... because I tried to get into a new chunk. But, you know, it was just like a collision when I tried. So I just want to make sure, I guess. That was a bit weird. And I think it's because of collisions. Again. Okay. So we are here. Actually it's fine when I move like this, right? So what's the problem? Like if I go here, is that down? There's no problem here. Okay, there is a problem here. Oh, is it because it's trying to load something? Oh, I think I have an idea. It's because for collisions, this is 25 minus 1. And we have a valid chunk, and it should not be a valid chunk. So let's try again. This should be wrong. Instead of clump. Well, clump is fine, I guess. But, let me go here. 25 minus 1. And this should return something not possible. So let's go, we have modulo. Oh! Wait. There's only one tiling type? Oh! Oh! That's a problem, isn't it? It's supposed to be this. And... can I copy and paste those? So here, instead of this, we have this. And try add node from cards. Try add node from cards. We have this. Okay. And now, what is that? Can I? Can I ban? Yeah, I can. Sorry about that. Okay, so we are going to have a loop again, but this time we are going to switch for all tiling type for each axis. For each axis, we're gonna switch. And wait, what's going on? This. Yep. So if it is clamp, then we return null. And for the white dimension, -1 is a clamp, so it's gonna return null. And it's gonna be good. Good. So now it should work. Hopefully. Hopefully it works. Oh, I hate my code. I hate my code so much. Wait, there's actually a problem. Get neighbor. May not be really large. Huh? Did I? Oh no. I removed the local function definitions. Yeah, I removed the... When I did this, I forgot this. I forgot to bracket. I removed one more bracket I should have removed. Okay. I'm really gonna fix things, because right now I'm like hard coding values for the torus too, but ideally I want it to work like in a flat, as a flat plane too. So yeah. So if I continue, now we have the terrain, and if I go down, it's still not working. New chunk is valid, even though it shouldn't be. Repeat, clump, repeat. So the new coordinates are 0, -1, 0. This is all according to the Keikaku. And now we have tiling types, so we have the clump. So this is fine, modulo. Oh! Huh? That's interesting. Then we loop again. Yeah, I forgot to remove this loop. But we have this. And this one is 1. So this is clamp. So this is here. And we have the chunk coordinates. Wait, that's chunk coordinates, not... Oh no. Oh no. Yeah, I mean, of course it's not gonna work. It's this, not coordinates. And I can remove this. And things are good now. Please, 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 let it be good. Please. Okay, so tonight we are supposed to finish the collisions, the custom collisions. But to actually, other than this, other than adding collisions to like all the chunks around, we also have to handle the normals and the minimum translation vector, and you know, sliding and that kind of thing. So let me just get this. So we have the game, and if I go down, it's still... How is it possible? I don't... Wait. Huh? It's not where the problem is. Wait. Where is the problem then? It's not there. Wait, can I pause? Oh no. Is it valid? -1. Nope. And this is a problem from 2, 0. So this is a visual louder this time. It's a visual thing. Because I have cube from. How is that minus? How is that -1? Ah, oh no! That's why I split the collisions from this kind of thing the first time. Request. Yeah, why is this one -1? Oop. 1. So this is modulo, so it shouldn't be -1. So the only reason it can be is because of this. Clamp, repeat. And this is called, what is that called? Find nearby chunk. Tiling type. This one is a bit wrong. Repeat, clamp, repeat. The problem is that it's wrong in some ways, but yeah. So, okay, technically you can say this is fine. Then we have this, and this is the node coordinates, right? So it's not chunk coordinates though. Maybe I should rename that. And yeah, for this one, this is wrong. Find neighbor chunk. For this one, this is wrong. I don't need this at any point, because this is a chunk that we find. So, technically I can just remove this, really. Yeah. Wait. I mean, technically I can just do that. And remove this. Okay, good. And now we still have some tiling thing. Try add node, tiling. Why do I have tiling? This get neighbor chunk. This is not neighbor chunk, this is get neighbor node calls. This is a big difference. Okay. Okay. So this is node calls. Then we have, wait, removes. What's the problem with this one? Right. Oh. Okay, I get it. Okay, chunk cards, let's keep this. But this one, wait. This one specifically is not cards. And this one is not cards. Here we go. I mean, we do need to put like an error if it's not in range, I think. But yeah. Well. I mean, I already compiled. Let's reset. Okay, so now we have all of this. We continue. We continue. Boo, boo, boo. And there's infinite loop again. No! Why? Why are you doing this to me? So Xenogy minus 1, 1. Modulo equal modulo minus 1, 1, 0. So this is good technically. Let me register. Oh, this is bad though. This is bad. Wait, chunk cards. This one is bad. Wait, we do have the repeat though. Well, we do have the modulo, I mean. Wait, what? We have the modulo, but it doesn't modulo. Wait, what? What's this? Wait, we have the modulo, but it doesn't modulo. Minus 1, 1, 0. Minus 1. Okay, we go in. Minus 1, modulo 26. Plus 26, modulo 26. So we go out. And it's supposed to be 25. Okay, so this is good. Then we have... Oh, I forgot the I. That was stupid. Okay, that was a silly mistake. Let me take a look at something to do in the meantime, just optimizing. This one. What? Never mind. So we have this. Okay, now it's not crashing. We go down. And okay, it's not crashing anymore. Perfect. Wait. Okay, so we have collisions. We have collisions. This is good. What about if I go here? We don't have collisions. So we still have to deal with this. Wait. I have collisions here. Yeah, that's normal, but not here. Yeah, okay. This is normal. Well, this is normal. This is something we have to fix. But that was already a problem before. So, yeah. Okay. So how to fix this? Let me first go to my collision loader. And we have sorted chunk indices, Let me actually go in thread generation loop. We have the observers. So I'm gonna go in because we only have one. Well, this is equal, so this is fine. I'm gonna try to go here. So I have to move to a new chunk because this one I can go through. I want to go like over there. Okay. So is this loaded? Okay, it is already loaded. So we continue. And what was a collision? Is a collision loaded? This one? It is already loaded. Well, it is supposed to be. Chunk to process. Oh, this is why. Okay, yeah. The problem is that we get the chunks. But we're not supposed to get the chunks. We are supposed to get the nodes. Okay, so this is a new problem. That's fine. Architectural problem. But this is fine. This is good. It's good. I mean, for this case, in this case, I really want a chunk collision class. That's what I want to say. Yeah, I messed up. So technically I can get processed chunks. I can get a node, right? This is a node of the graph. But the problem is that I want to load... I mean, I do want to get the chunk though. To like load the chunk if necessary. But then I want to load this. And the collision load state should not be inside the chunk. It should not be here. That's the problem we have. Well, that's one of the problems we have, because it feels like we have another problem. Register collider. Oh yeah, there's this thing too. Because we generate for a chunk, but we don't have the position. Right. What? Yeah, we have a lot of problems. Got it. Got it. Ah. Yeah, for some reason I thought this would be solved very kind of easily, but we actually have to do a lot of things. I have to think. At first I wanted to try to optimize things by not having collision chunks. Like a new class instantiated for like every chunk, like for every collision. But I think it's gonna be necessary. So that's a bit of a shame, but yeah. There are so many problems. So what I want is, I technically want this boolean for each, well, no, this boolean for each node, right? I did like what I had though, but with this thing, but it seems like it's not good. It's not good. We can't have that. That's a shame. I mean, technically I can, but that means I'm gonna use a hash map for to like retrieve my collision chunks, which you know is possible, but it sucks. Okay, so let me write something. I want to write problem for each one of my collision chunks, we can say. I want additional data. For example, whether it's been loaded, being loaded, etc. Wait, is that true? Technically, I can just look at the server for that. Or I can just have a hash map, maybe, in the loader directly. Because it's about the loading, right? So technically, I could just have that. But then, if I have like a hash map, is it going to be thread safe? No. I mean, if I create it as a beginning... And then we have this, but that's another problem. So chunk to process, we get it. Do we have the position? Well, we have the node, right? We have the node that we want to process. So I'm gonna get this instead. Nodes to process equal this. So I can remove that. Here we go. Okay, and now thanks to that, we're gonna be able to do a lot more. So I mean, technically it's just this, right? Okay. So yeah, technically what we want is something like this, but the problem is that we are using the node to check for equality and that kind of stuff, and we want it to be kind of agnostic of, you know, the other things, right? So we can't really do that. Instead, what we can do is have like some kind of hash map that contains this value. Would be fine, technically. Technically, it should be good. I can initialize the hash map at the beginning. Yeah. I don't even need to allocate anything because, I mean, the hash map is gonna allocate. Even though it's gonna be in an array, I suppose. So we check, then we store, and when we register the chunk, okay, that should be, we should be able to do something. So we're going to have something called chunk collider data, and we're gonna have a hash map from a node to the collider data. Like this. Chunk collider's data. Okay. And I mean, if we put it in the mutex, there's like no problem either, right? But I mean, technically we can just put everything in the mutex, I suppose. So let's say we have get or add, insert, and you have the value. Let me check this again. Oh, so we... Okay. Let me... Has, insert, I guess we just want to get. Like this. Then we're gonna have the data. Collision data, let's say. And then we can check this. Well, this. So we're gonna remove this. We're gonna move this in here. Node state. Okay. Have this. Boom. Boom. It's not really safe, but eh. Yeah, I mean, technically I want it to be a pointer, I guess. But maybe that's fine for now. Wait. So we have this, we have this. And we compare exchange strong with this. And technically it should be the same, I know, but well. And same here. No, you know what? I'm not gonna do that. This is one thing I'm not gonna do. Here we go. It's a bit better like that. Okay, so now we have this, and the only thing left is that we want to register the collider with the position of the node instead of the chunk. Well, I mean, not register it actually, because this is fine. We want to, well, generate it here, right? With the right world coordinate. So right there we have like a start position, and this position is wrong because it's not using the positions of of the node. Well, okay, never mind. Yeah, I guess it's not found because I have to insert it, but I want to insert it ahead of time, like right there. Like this that find, well, has, if it has two for each node, do I have that? Process chunks. Yeah. For this inside. Oop. For this inside, then we check this. If it has the nodes, then it's good, but if it doesn't, then we insert new. And this is going to have the node as a key, and the value is going to be, well, just a new this. Okay. Now at least it shouldn't crash anymore. Okay, shouldn't crash, but we still have the problem about the loading of the chunk of the collider. Atomic. Oh no. It's because of the copy or something like that. Attempted. Yeah, okay, it's a copy. That's why. So I need to allocate. No! I need to allocate that. I mean, I guess that's fine. It's not that much of a deal. I mean, it's still something I don't really like, but I guess we're gonna go with this. Now we have a few problems. We have this, And I guess I can make this a little bit better. Instead of creating a new one there, I want to create new ones one by one. So I can go here. It's in the mutex, so it's safe. And I'm just gonna check if this has the node to process. If it doesn't have it, then we insert new. And well, I guess I can get a pointer, more like an index. I mean, pointer is actually probably better, but yeah. Yeah, let's try to go with it. So we have this. Then we have... Oh, can I just do... like P? Well, that would be the opposite, actually. Let me... Okay. Okay. PTR. So we check this, and if this is null, yeah. Actually, let's have this, and we have this equal this if it's valid. So I can remove. And now we have the insert new with the allocator, and we have the value, and we do this, and we can remove that because it's gonna be that. We have the node, and we have to make a new. We need a maybe a mem new for now, it's fine. Ideally it should be like the page allocator maybe, but let's say that's fine. Let's say that's fine for now. Left of Nana must have class right. You're right. Boom. Okay, let's continue a little bit, and because we have the nodes, right? We have the node to process. So we should have like the position. Wait. Okay, we actually don't have it. But let's do this. I mean, what I mean is that we don't have the data from this because it's like a polymorphic class, right? But that's fine. Where's just our chunk? I mean, I guess technically it should be just the node and not the chunk, because we can get the chunk from the node. So this should be fine. And let me show you this. We have the game. We can't collate here, but we can collate there. So this is good. No problem. We don't have any crash even if we move. Good, good, good. Good, good, good. Okay, we do have a crash, but that's fine. This one doesn't count. So we have the node to process, we have this, and this one is gonna go in the generate. Okay, I'm just gonna forward this instead. Yeah. Seems like the thing to do. Boom. chunk is undefined. Oh no! But now we know that it's a cube chunk voxel collision thing. So what we can do is we can cast this to cube chunk space maybe graph T repeating graph, and we have the node cube node to process equal this. Wait, is that the repeating one actually? It doesn't really matter, does it? Does it? No, it does. Yeah, never mind, it does. So okay, we have this. So now we want to cast it. Like this. It's a bit big, okay. My apologies for that. 1, 2, and 2. Yeah. Okay. So now I can get the data and the chunk, more importantly. So I have the chunk. Actually, it's already a cube chunk, so I don't even need the cast. Oh, that's nice. So we have this. Then we have the coordinates, and we're gonna use that instead of this. Data.cores. Here we go. I'm just not sure. Is this -1? Is this good? If it's like -1 in X, then it's gonna do -1 out of that. I don't think it's valid. Let me go in the... Okay. Let me go in the cube chunk space and take a look at this. To the chunk cars. Yeah. Generate all the chunks. The minimum. I feel like this is linked. But NV blocks. I'm not sure about that. Oh, actually, I think it's in the collision space, maybe. But I have something like that. So here, I have... well, cube chunk space, actually. Yeah, this is it. Yeah, this is it. No, this is the wrong one. This one. And we have 2 cube cards. Oh, and 2 chunk cards. And this thing. That is really big. Okay, this is what I want. Probably. Is it? Collision, sim, cube cards. Yeah, okay, this is what I want. Probably. Is it? Why is this? Why is there a cap here? I mean, that makes sense. So... -1. Does it? And we have the remainder. Amount of loops is the amount of chunks. Okay, yeah, that makes a lot of sense. I'm just not sure about those coordinates, but cube coordinates. I mean, okay, this is right, but this is for cube coordinates. And I don't want cube coordinates. That's the only thing. I want chunk coordinates, but that's the same problem. So I'm just gonna copy everything. It's actually in here. Well. Well, I'm supposed to convert to world coordinates though, so I'm gonna have... What was the thing again? Sim cube... to sim cube chunk coordinates. Oh, so I basically want the opposite. Well. Okay. Okay, let's have a function there. Collision chunk cards to collision cards, maybe. Okay. Chunk coordinates. Okay. Then I have start pause. So we have vector 3 start pause equal just this basically. Yeah, just basically this. Good. And now I just need to do stuff, right? So by default, for positive values, this is correct. Well, I mean, I guess I need some data, but this is supposed to be correct. Then we need the space. Moshi Moshi, hello Hyundai, how are you? Space. Here we go. Wait. Here. cube space, so this is good. We just need the space there. Okay. So by default we multiply, but the problem is that if one coordinate is negative, we're not going to take into account the modulo. So let me go back to this, and I'm just gonna copy that, you know, just to check, just for it to be on the same file. So we have the amount of loops. So we have, so instead of cube coordinates, it's well, NB cubes, it's the amount of chunks. So we're gonna still have this. And this is NB chunks. Vector 3i. NB chunks. Okay, so we have the same logic. We divide by this and modulo, but this one is going to be the chunk coordinates. Same logic. Wait, is it? Oh, wait a second. Oh, it doesn't work. Oh, right, it doesn't work. I mean, that's why I had... Right. Okay, okay, get it. Wait, what? Oh, that's when I closed it. So instead, can I make it a bit better? But yeah, it's by... I mean, you know what, I'm just gonna copy this. Not a big deal. So we have all of this. And it should be good. The only difference is that I have to compute the cube coordinates, isn't it? Or is it? Yeah, but then I have the same problem. Oh no. Reminder. Yeah, okay, no. Okay, so you know what? Let's go there. I'm just gonna... So this is the positive position. And block size. This is supposed to be at the end. So we're gonna have cube position. Like a chunk, well, cohesion chords equal cube cohesion chords. We have something like this. Then we multiply. And this is valid for positive values. But then let's say it's negative, so we are going to have reminder. I mean, technically, kind of. I mean, technically, we can just check if the value is negative directly, right? So something like this. We can just do that. Is negative. Okay, this is it. So we check if this is negative. And if this is negative, then I... let me think. instead of -1, so okay, if this is negative, I can do +1 and minus. Well, +1 for the chunk coordinates, but I guess I can do plus this, but minus the remainder. That's the thing. So I can do something like. By the way, I'm curious, when people say how are you, do you respond how are you, or respond by I'm good, how are you? I mean, I would say the second one, usually, I suppose. Like I'm expecting an answer. I know some people don't, but yeah. So plus equal this times this plus. I'm good. How are you? I'm good. Thanks. So this plus like minus, I guess. Minus what? Minus the remainder. How did I get the remainder? So we have the default cube chunk size and update. Yeah, how can I? Oh, it's the minimum between the amount of cubes in total and this. Well, between this and this. Chunk start. Huh? Right. Let's do something like get remainder chunk size, and this is going to be maybe the amount of cubes minus wait minus what? I guess it's supposed to be modulo default size. Oh, right. Yeah, that makes sense. It's just that. So cube space gets remainder chunk size. And that should be good. So when it is negative, when it's positive, I multiply by 0, so it's just plus equals 0. But if it is negative, then it's 1. So we have a plus default chunk size. So -1 will go back to 0, and then it has a minus remainder chunk size. So, okay, should be good. Is it actually? I don't think it is. Because it's not about being negative, it's about the modulo. Oh, I think. Like we have the coordinates and it's about this modulo the amount of chunks, I think. That way, if the modulo is 0, then everything is fine. If it's 1, then you do -1 default chunk size. Wait. Minus? That's the opposite. Yeah, you do minus this, and you add the remainder instead. And when you go into the negatives, then -1 times this, so you do a plus, and then you remove the remainder. Okay, so this should be good. This should be great. Let's try this. And what is right? Let's remove that. And we should technically have colliders for every chunk, even though it's not very clean. I probably want to spend some time cleaning this before continuing. But yeah. But yeah. Okay. Boom. So do we have collisions there? Actually we don't. Huh? We don't even have collisions here anymore. Wait, here, I mean. Only at 0, 0, but that's not really what we want. Wait a second, something is wrong. Let me go there. Chunk card -1, 1, 1. -1. Wait, is that -1? It's not supposed to be -1 though. Ah! But okay, let's say this is fine. So we have -50, 50, 50. Sounds good to me. Yeah. And instead of -50, it's supposed to be something else. So let's look at this. -6. Which sounds good to me. I don't know about you. But to me, it seems like it's good. But for some reason, let me just take a look at this. Is that equal? So we have the times get block size at the end, so this is good. This part is fine. Then it's not really negative, it's the modulo. Wait, is that... Oh, that's not the modulo I want, though. That's the division I want. It's a division. It's supposed to be a division. Here we go. Repetition count. Here we go. Repeat count. Wait, what's the name of this music? Beneath the Mask. Ooh. From Persona. Persona 5. Okay. Compiling. Yeah. Two hours. Okay, here we go. So we have collisions. They're back. They're here. Good. What about this? Yes! Okay, I don't have collisions there though. Okay, what about there? Okay, I don't. So this is interesting. So I have collisions there and here. What about if I go like here, for example? Okay, I don't have collisions here. Interesting. But I have collisions there. With this chunk. I'm not sure why this chunk and not the other ones. Yeah, it's a big chunk, but the limit is... Wait, what? Collisions, no collisions there. Huh? It's not even the middle of the chunk. Wait, that's weird. I do have collisions there though. Oh, is this... Oh. Collisions. Then we have collisions. Collisions. Oh, okay. Collisions. No collision. Wait. What? I mean, this makes sense. I don't really understand this. Feels like there's still a few problems, but okay. Yeah, we have like a mini chunk here. Yeah, why is it only working for like... I think it's Z, or like X or Z. I think it's Z. Let me go maybe around there. Oh. Ah! So we try to generate. Coordinates are 20... Wait, oh no. So we have 0, 0, 0. So it's just... Oh no. Is it supposed to be 25? Don't think it is. I think that's the problem. So what does the note say? The note says 2510, which is wrong. Because I haven't looped around, so it's supposed to be minus. Wait, yeah. Okay. Wait, I'm loading this again. $24. What is the observer? Collision chunk, okay. Collision SIM cards. Oh, that's why. Okay, that's collision SIM cards I have to use. I used the wrong one. I mean, do you ever sleep? Yeah, I do, man. I've only been streaming for 2 hours now. Yeah, that's the problem. Chunk cards. Oh, so I don't have the collision. That's Euclidean. Why am I setting this? And not this? Oh, probably. Well, okay, I'm gonna do that. Is it possible to make it so you can look at the collisions instead of touching if you're there? I can, but it's a pain. I tried rendering things a little bit. I tried rendering the collisions a bit, but I mean, it's like easier because, yeah. Because it's like not about like any collision. It's not any collision that I'm testing. It's really the collisions of. I mean, okay. I guess you might want to like render the collisions on top of my torus. I mean, I could, but it like requires some work. It will require some work to like for the collider to follow the distortion and stuff without affecting the pickup texture. Okay. So right now I have a new chunk. I think I need a new one. I'm just gonna copy all of this. Boom. A new chunk, then no. Well, I'm not sure about that. Yeah, that sucks a little. I'm gonna try something, but I'm not sure that this is gonna work. I'm just gonna use the collision SIM cards there directly instead. So I try to find the chunk. If this is different, then na. And this one is collision SIM cards. 2 chunk cards, I guess. Wait. This one is... You know what? I can just divide. So this divided by cube space this. Okay. And you have chunk coordinates. Everything is a mess. That's fine. So now I can get the key and we have the new collision chunk, which should be good. So now we should find the new thing. The new collision chunk. And when I try to load, I'm gonna load the right one. Get chunk collision node. We return this, which is the right one. Okay, well, it should be the right one. Wait, I can't move. I can't move, oh no. Wait, I can't even get back there. Is there like a loop process? Huh? What? Chunk constrictor. Huh? Instantiate. So it's like creating more and more. What's that? Not chords, -1. Oh, that's why. Wait, -1 and it's not... That's a node coordinates. So it's repeating. Okay, this is good. Well, good is a way to say things. So I have the node coordinates, which is fine. Then I have the chunk coordinates, which is fine too. I register, Then I update the neighbors based on the node coordinates. So if I go in, for example, I have -2, 1, 0, which is fine. I try to get the neighbor node. And if it exists, it does exist apparently. Then I update the neighbors. And this is perfect. No problem so far. But, yeah, so this is valid. But then the neighbor is 0. Well, it's null. Is that it? Again. Okay, I don't know why. I don't know why it's not updating. So 0, 1, 0. Wait, is that the one? Wait, no. Neighbors. Okay. Let's try this 6. A. Actually, no. Is this that's PTR? That's a nice way actually to visualize arrays that are inside pointers. You can just write this with like a command. This works. So the current node to process is 0, 1, 0. So we go there, we request loading. 0, 1, 0. With like a specific neighbor, right? Yeah. So I get the neighbor coordinates. So this is not coordinates, but yeah, this is fine. Wait, this is -1, 1, 0 though. I mean, of course it's not gonna work. Well, I mean, we're supposed to generate from this, actually. Never mind. This is fine. Good. 2510, so the coordinates are good. 2510. I find or create a node. I think I find it. -110. Wait, yeah, that's the data. But the chunk is like 25. Oh, it's actually nothing. So I set the coordinates. Good, I register. Okay. And then I'm supposed to update the neighbors. So when I do that, for each neighbor, chunk. Yeah, I guess. So if I go in, zero, I mean, yeah, it doesn't exist for this. Actually, it does. 24. It seems like it actually does. But okay. Okay. So we assign the coordinates are going to be -1. So -210, which makes sense. So we try to find. And it did find. So then we do update the neighbors. Wait, this is actually... It's actually fine. Neighbor node. Huh. So this one is supposed to be a bit different because we are supposed to have 1 and this is 100. So we have the node coordinates -10 and now it's going to be 010. So we find the neighbor node 010. Right, this is good. We have the over index. And now we have the first one is set. And for this one, actually this one is completely set. Yeah, 010 is completely set. Wait, what's the problem then? So this is valid. I step. This node is 010. Yeah, so wait, this is the same. But neighbor is null. So wait, there's something wrong with what was it? Let me go out. Processed chunks. There's only one processed chunk, and it's 010. Wait, that's crazy. So, huh? Space. We have this. Cube Torus. No, I don't need that. Do I? Maybe I do. So we have this, we have the repeating graph. Right. with some things that are valid. Chunk graph, okay. Data to nudge. We have different things. We have the size. Wait, what? That's crazy. And we have, for example, this 2500, which is 2500, and this one is chunk cards 2500. So this is correct. So I don't really get the problem. Data. I mean, yeah, the data is the same. Is it? Yeah, it is. Neighbors. And neighbors are null. I don't understand that. I mean, I think that there was like a problem in the first place. And the problem is that I'm storing chunks, but I don't actually need to store chunks. I just need to store positions in my graph. That's the only thing I need to store. Technically. Can I do space, repeating graph? Okay, let's continue a bit, maybe. Okay. What if now I do repeating graph? Good. Dot data to nudge. Dot elements. And this is the amount. Okay, so we have all the chunks we tried to load. And let's try to see if we have the same coordinates. It doesn't seem like we do. Why do we have so many values though? Minus... Oh! Oh, look at this! Oh! That's a nice finding. Oh no. So when it goes to minus, there's a problem. Because, wait, actually, why is... There's a 25 there, and 49. Why is it starting with this? Doesn't make any sense. It seems like very unique though. And then we have 2. Then we have this. I don't get it. And like with a new chunk every time. Wait. I saw something. Yep, there. So we have the first -1, 1, 0 for some reason. And then we have everything here. It goes to the negative. But we do have a -2, 1, 0. But yeah, just with like different chunks. That's crazy. That's crazy, I don't get it. I mean, it's when I'm adding to the graph, right? So it shouldn't be too hard to debug. So repeat thing graph dot find or create. It's only actually I have it at 2 places. Wait, what? Try add from cards. Oh, that's why. Try add chunk from cards. I'm doing this here too. I shouldn't be doing that, I think. I'm not even using this. Yeah, let's not do that. And then we have this. With the graph data, and we have the cube chunk that seems to be different for some reason. It's the new chunk. Oh, I get it now. I get it. Yeah, I mean, before instantiating it, I guess I have to check the... Can I do calls to chunk index? I guess? Oh, that seems like the kind of thing that's going to lead to a lot of problems. Can I find chunk like from cards? Get chunk from cards. Something like this. Find we have the coordinates, and it is returning an iterator. So I have a get PTR ID. Wait, what? Huh? Isn't that supposed to be good? Value. Huh? Is it... I mean, technically I can do this. If index equal... No, wait. If this is null, I return null. And else I do this. No? Not good. And I cast, I guess. So now that I have the coordinates there, chunk chords, I can call this. I can find the chunk. So something like this. And if this is null, I instantiate it, and that's it. And I guess it's a cube chunk. So I can do this. Then I can check if this is good or not. Cube chunk. And it should be fine. Okay, and yeah, what's the problem with this? Let's restart, but I'm not sure. I don't even know how it was working before, with that many bugs. Okay. So, cannot convert const t-value. Oh, it has to be const, that's fine. Got it? Wait. Is that all? So const t-value star to this star. What if I do... I still don't get it. I still don't get it. I mean, okay, maybe it's const. That's fine to me, but... Cube chunk cards. Okay. Can I go in? Undefined type. Oh, that's why. That's why. Well, that's not why, actually, it's just IntelliSense in that case. That's fine. Okay, here we go. Now it's good. Phew! Phew! That was a lot. That was a lot. Too big, undefined, and now. And what else do I have to do? I mean, technically now I'm only spawning one chunk, so it should find the same chunk because we are, you know, looking up for it. Okay, so we don't have an infinite loop right now. Actually, we do now. What's the problem this time? I don't... I feel like I want to just restart this. But well... Step! So the problem is surprise neighbor is null. Right. What a surprise. So now when we go in, we try to add the new thing. Oh, my bad. That's fine, I can just go there. So the node is always 0, 1, 0. Or it wouldn't be that fun. And neighbor index is 0. Okay. So we continue. Chunk card. Ah, it's not cards. Boom. This is 25, 1. This is -1, 1. Perfect. So I tried to find the chunk. And I mean, there's like everything in here. So that shouldn't be a problem. Why is this? What? What's that? 0, 0, 0 is like more than the max. I think we have a problem here. Don't we? Yeah, we have a few problems. And 2510. Wait. What is that? What? So this is supposed to be good. It's supposed to be the last one. 2510. Huh? The index is wrong. Oh my god. But this is actually valid. 2510. Whoa. It's like spawning the same chunk multiple times. It seems. I actually just realized something. But I can just ignore the chunk in the hashing function and the equality of my custom data type. So yeah, there is definitely something wrong here. When I push this, I think it's when I register chunk. I register there. Oh, I mean, there is a problem here too. Well, here too. Let's go to here. Not here. Try add node. This is fine. And we have... Okay, this is fine. We have this. And we are instantiating the chunk directly. This is a problem. Instead, we can do this. We try to find it, and only if it doesn't exist, we register it. But, oh! My bad. Yeah. Yeah, I mean, I don't need all of this. Okay, I get it. I can do this, right? Well, I have to do this. Yeah. Okay, I get it. And it's like the same for the other registration. Wait, what was that? Here. So I'm going to register the chunk. Yeah, here. Wait, but find or create. No, that's fine. Because I'm only doing this. As long as I do this before this is fine. So now I can remove. I don't have to register it again multiple times. Good. And now for all neighbors I do things. I'm just gonna restart and look at this. Sets enemy blocks uninitialized. I mean, this is just an amount, right? Wait, is this? Wait a second. It's supposed to be inside. Okay, let me just do that. Okay, yeah, should be good now. I hope. I really hope. Hey, this is sick. Wait. No, it's not. Why I got scared? Wait. What? Where was that from? Oh, it is. Okay. Let's continue. So this is good. This is not good. I tried to move like one finger and nope. Let's pause. I actually don't even have... What? Huh. This is interesting. Oh, okay, here we go. Okay, this is gonna be a surprise, but I'm gonna continue. I'm gonna go here. And whoa, the neighbor is null. And it's 0, 1, 0, isn't it? Yep. Surprising. So we go there. We go in. This is good. Actually, is it even like returning something valid right now? So this is valid, so it doesn't add the same chunks multiple times, which is good. Which is like a good change. Chunks. Boom. And yeah, what about wait. There was chunk to data to, yeah, this thing. Data to node. Well, not data to node, but chunk calls to chunk index. And now, like, everything is good again. This is good. This is fine. But it shouldn't be an index. It really shouldn't be an index. So, okay, we have this. We find or create. So that's a find, right? If I go inside, how many elements do I have? Yeah, I don't have a lot. Okay, this is good. 9. Yeah, this is good. All around. Okay, this is perfect. So I have it. -1. Then it's gonna do -2. Find neighbor chunk. Okay, it did find it. So with the coordinates, so that doesn't exist. But it does. But how can it exist? Wait. Okay. So we have all of those values. Wait. It's only supposed to go to 9 though. Right? So something like this. I don't even have... Oh, I do have 0. 0, 0, 0. 1, 2... Oh, never mind. I guess that's fine. Yeah, I guess that's the first one. Well, I don't really get it, but okay. And this one is added again. Let me verify that. How many elements? 8 or 9? 9. So why do I have this one? This is not good. I mean, okay, I set it. Why not? What about the one? So right now we have -1, 1, 0. So if I do +1, it's supposed to be 0, 1, 0. Yeah. And do we find it? Normally, yeah. We do. So we set the neighbors. Wait, okay, so I have a question. Oh, wrong one. Step. Let's go in. So the neighbor is null. But what is that? 0. And the node is 0, 1, 0. I don't get this. Actually, what is next chunk index? What is 0? How can this be 0? Did I clear? Did I reset? Wait, what about... Is this equal... F0, E5... Wait. Oh, that's not E5. So we still do have a new chunk that is assigned... That's weird. Okay. Let's go here. In. Okay, so... Let's go. F0... Well, this is... 36 F2, and we don't have this here. So why is this... Well, why? That's a question. Why? Value... So I mean, this one is gonna be wrong. Because it's gonna find the first one, and not this one. So okay, this one is never gonna be set because... Okay, so that's a different error. That is due to adding the node. But we have the wrong chunk for some reason. Oh, what was that? But the coordinates of the chunk are 0, 1, 49. Wait, what? Huh? Why? And this one is value. Oh, because it's looping in Y? No, it's not looping in Y because otherwise it would be like... Never mind. And... Wait, it's looping in... It's looping in Z, actually. It's doing a -1 in Z. And it's getting back to 0, 1, 0. Instead of going into the negative. That's interesting. Okay, so what I'm gonna do is when I register the chunk... Actually, I don't know, because I already had this. Find or create. So it didn't find the... I guess it didn't get assigned. No. I mean, I do want to make like an asset or something, because that's like the kind of thing that could be fixed very easily with an asset and like more checking. But yeah, I'm not sure about that. Find chunk. Find or create node. I mean, technically it's supposed to find. And yeah, the question is, why is 010 assigned to 0149? That's like so weird. That's like so weird. Like just that doesn't make any sense. Because it's like a difference of 1. Like it's not the same, technically. Like that should be -1. So coordinates 010. Find chunk from cards. Let me get here. So we have this 2510. So -110. Huh. Wait. No, okay, yeah, this. Let's create an asset or something. Let's make an asset. And the asset is going to be that. This. Well, let's have a OR crash. Like, crash count. It's gonna crash if the coordinates of the chunk are not equal to the node coordinates plus, well, pos modulo, right? Pos modulo of this with default chunk size. Wait, that's not default chunk size. That's like NB chunks, my bad. And what is that? If it is equal, we crash. Good. And the problem here is that this is cube chunk cards, and this is something. That's fine. Wait. Vector free I. And technically we can have this. Okay, good. Let's do that. Let's check this. Wait. Yeah, if it's not equal, I crash. Okay, let's go. Now we should find. And yeah, I was saying that, well, I mean, the chunks should be fine, but I was saying that in here, or like, maybe not here, actually here, instead of like having the equal comparing the chunk, I can just compare the coordinates and it should be fine. So, okay, let me just continue. Revert. Okay, here we go. And now I crash. Do I? I'm not even crashing. That's so weird. There's no crash. But when I go here... Wait. When I go here... And I check the... chunk codes to chunk... Well, not this. Chunks? No. This? Zero, 1, 0, no. Yeah, I still have the 0, 1, 0 there. So I don't get this. I don't get this. I don't understand. Please. Find or create. But yeah, technically... Technically... Okay. Let's go here. We're just gonna return this. Ah. Return. It's gonna be the hash of the coordinates. We don't need that. We don't need that. And we are just going to... Oop. We're just going to crash here if cube chunk is not equal to node data chunk. Okay, here we go. Here we go. And this should be the test that's gonna tell us everything. It's already midnight. Wow! Why is it midnight already? I did nothing. It's just... my code is just so bad. Ah. Yeah, I wish I made a new collider space and chunk and that kind of thing. Maybe. That could have been better. Like split things a bit more, I don't know. I mean, I would still have the same algorithm though. I'm not sure. But not the exact same. Okay, so we have this. I move. And I don't have any problem right now. What the fuck? So this is actually good now. So I have collisions. But I don't have collisions there. So those collisions disappeared. Interesting. Wait, I have collisions here. Huh? Oh no, this one is fine. That's normal. This one is no collision. Okay. So I still do have some problems. And actually, you know what? Never mind. Yeah, I was sure I was gonna have a crash. I was sure I was gonna have a crash or something here, but it doesn't seem like I will. That's weird. Can I? No. That's weird. Oh, because I'm setting the new data though. Wait. Oh no. Wait. No, that's fine actually. No, never mind, that's fine. I just find it. Yeah, why is it not crashing? I'm only doing this here, right? So let's go there. So you have cube chunk that is 2520, and this one is 2520. Yeah, that makes sense. Not chords are -120. This is completely fine. This is completely fine. Wait, this is completely fine actually. I have no idea. I mean, neighbors are set. They are set. That's a fact. So, huh? Is it because of the collider this time? Because there's no infinite loop anymore. So is it because of this? -310. Oh. Let's go there. So we have the amount. We divide. What? Oh, chunk coordinates. Wait a second. Wait. Oh. Right. I get it. If it's negative, then it's supposed to be -1. That's why. When minus equal, what was it? Vector 3i. This dot x. Well, basically, can I just do this? No, I can't. This dot x less than 0. This dot y less than 0. This dot z less than 0. And if this is true, then this is 1. So we have -1. So yeah, because basically with the division, like if it's like 2, just all of that divided by 10, then it's gonna be 0. And if it's like -2, -2, -2, then it's gonna be 0 too when divided by 10. So we don't want it to be like the same value for both positives and negatives like that. So instead we do a -1 in that case. So we have like squares. So we keep squares, like rectangles, you could say, of repeat count. Yeah, if you don't understand what I'm saying, this is fine. All that matters is that now it's supposed to be good. Because if it was only a problem of like collider position, then I mean it's not that bad. Like if I go there, I actually have no collision. Wait, what? I have a collision here. I have a collision here. Wait, so I have here, I have here, I have here. Good, good. I don't have here. But this one is like a bit special, right? It's like a mini chunk. But then this one I don't have either. What about here? I do. What about if I go far away? There. Okay, I don't anymore. This one has collision though. Wait, what? How is that? Okay, maybe this one is a problem of... wait, I do have collision there. And not there. Oh. Now I can't go back. Oh, what? What? Let me go out. I actually can move there, but not... I can't go up, I can't go down. So I think this is a problem of how to call it? Of the algorithm. I think my algorithm might have some problems. And yeah, so this is fine. This is good. What about this one? No. 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 Let me go in a straight line. No. Okay. Yeah, there's no collisions. And here? Nope. Wait, what was that? Right. No, that's fine. And we have collisions here. What about in the distance? We do have collisions here still. So those are still valid. Okay. I mean, we still have a problem about the... it's not only a problem of colliders being broken or like the collision physics and stuff. It's a problem of the spawn, I think. The spawn is wrong. Or something like that. Like if I go there... Well, actually... Let me go back to the origin. So this is 0, 0, 0. And I'm gonna go in this direction. Straight line. Actually, bad example. Because this one has collisions. But I'm gonna go in this direction then. Wait, there's a collision here. What the fuck? I have a collision here, I can't move. That's crazy. What? Okay, here we go. So we have the coordinates. -2, 0, 4. What is the offset that is going to get computed? I divide. So this is 0, 0, 0. But there's a minus. Right? So we have -1, 0, -1. Which is good. Which is nice. Which is normal. This is normal. Oh, I understand why. Okay. So by default, if it was positive... Well, it's not positive, but the coordinates would be there. Okay. Now what we want to do is... I don't know. Repeat count. I mean, the problem is definitely with this line. That's for sure. But how to solve this? Because repeat count... It's like NB... I have to minus NB chunks. Oh, Wait, I get it. I had a similar function before, but basically I multiply the amount of chunks by the default chunk size. So it's like the size of my whole loop, and I minus that, which is a lot. Like minus 1. So it's gonna be a plus. Wait. I'm not sure about that. But yeah, I know that the problem is here. I just have to think a little. Do some math. This is simple math. Why is it so... Okay. Chunk cards. -2, 0, -4. So what we want. How do we get the world coordinates of that chunk from those chunk coordinates? We multiply. So if it is positive, this is good. But if it's negative, well, it's actually not good even if it's positive right now. Okay, let's think about it if it's like positive. And if we have repeat counts that is like 1, 1, 1, okay, like 1, 0, 0. So if this is so far ahead in the future, then this is repeat counts times the amount of chunks times the default chunk size. No, that's wrong. No, that's wrong. NB blocks. No. NB cubes. My bad. Okay, so this is like the whole loop. And what? And yeah, in the final position is gonna be... Oh, I have to modulo. Oh, I do. I have to get the positive modulo or something. Actually, okay, that's actually simple. So we're gonna have the normalized position equal post modulo of chunk cards with the amount of chunks. Okay. So this is always going to be positive. And then we have this plus this times the default chunk size. And this one should be good. That's it. That's all. That's all we need. Oop. Let me restart. Let me add this. And remove. And yeah, that should be good. And if it's like, if your repeat count is negative, now we remove everything, like the whole size of the donut, like this. And then we plus the normalized chunk coordinates times the default chunk size. I mean, it should be good. It should be good. There's no reason it's not good. Good, good, good. Okay, it's gonna run. It's running. And now this is time. Look at this. So we have collisions here, like before. Always working. And now 3, 2, 1. Yes. Collisions, collisions, collisions. What about here? Shit! Okay. We have collisions here. This is working. So it's working in 2 different axes. But it's not working here. And I don't get why. I don't understand why. This is weird. Because it's like -1... -1... -1, 0, -1, something like that. Is there something wrong with... This should be right. Okay, let me test a bit more. So this is fine. Good. Let me go over there. If I go down, this is good. Oh my god, this is... Oh, I'm so happy. I'm so happy. This is finally working. Partially right. It's still partial. But yeah, if I go like... Okay. What about if I go there? Is it working? It's not working. Wait, it is working now, actually. I can't move anymore. Wait, what? Please! Ah! Right, I'm not updating the collisions. No! Let me out! How can I get out? I can't. I really can't, actually. Oh, no. Wait, this is a problem. No, please! Okay. I'm just gonna restart. And then I'm gonna put a breakpoint to check a bit more, because there is still a problem, but I don't really know where. Divided. I mean, so divided is like dividing each axis, so that's fine. So we have this. So collisions, okay, everything's good. Let's move over there. And if I go down, I'm gonna put a breakpoint. Like here. If I go down, boom. Chunk cards. Well, chunk cards. -2. Huh? Why -2, 0, 0? I'm supposed to be in -2 something -2. Wait, that's a problem. Because technically this is fine, but it's not supposed to be the right place, is it? Wait, let me just look around. If I go like over there, and I go down, like down, -3, 0, -1. Is it? -3, -1. So this is probably good. -3. And this might be good too. I don't actually know if it is or not, but I can assume this is fine. But the chunk coordinates are not good. That's weird. Thread generation loop. Oh no. Wait, register collider? Right, yeah, no, that makes sense. Let me just check. Oh, I know why. Maybe. Like if I put a breakpoint there, and I continue in this direction, is this valid? -2, 0, -2. I feel like this is late. Oop. Oh, that's actually a very... -2, 1, -2. Well, I was gonna... Okay. So if I go up... -2, 2, -2. So it's actually alright. But for some reason... Oh! How I have my ID. Col P. That's Euclidean. Yeah. Okay, let me restart. But in the editor this time. Because I might have found the problem. It's the same one I had just now when computing coordinates. And I think I have this, I made this error in GDScript too. Is this one? I forgot to -1. I just divided, I think. And that was my problem. And actually that's supposed to be the case for the visuals too, now that I think about it. Yeah, but the visuals are positive, so just a division is supposed to work. Okay, so when I do boom, I have this and I have set collision sim calls. Let's check this. Well, actually, it's just the coordinates, isn't it? Actually, I'm never putting this. Wait, I'm never putting... Huh? Oh, no. Okay. Okay, my bad. But how is it right, then? Oh, because of this, right? Yeah, okay. So it's equal to the position. And then I do a positive modulo. Which is fine. Which is understandable. And yeah, okay, this is it. The problem is this. The problem was this. Found it. So I'm just gonna do this. Okay, here we go. Here we go, here we go. That was the problem. We can run this without the editor. And I mean, it should work now. Like, I have no, I don't think there's any reason it doesn't work. So that's great. And basically the problem was that there was an offset between what was, like the chunk, basically it was considering that the player was in a chunk that was closer to the origin, or like the positive values, than where the player actually was. And because of that, I think it wasn't loading some chunks. So we have collisions here. We have collisions here. We have collisions here. And we have collisions. We actually don't. But if I go, for example, there, like far away, and I go down, I still have collisions. And this is working correctly, right? No matter where I go. So this is something that is fixed, I suppose. This is one thing. Maybe, I hope. Yeah, it's good, right? Seems to be fine. And if I loop again over there, so this works. This works. What about if I go? So I don't have like hidden collisions here anymore. And I think that was the reason. Before I had like hidden collisions here, because I think it was, I don't know, using the collisions from there, something like that. We don't have that anymore, and we still have collisions there. So this is working well. Same if I go there, we still have perfect collisions. Same if I go there, right? Perfect collisions. And now if I go to the minus something minus here, it's not working. Wait, is it actually? It is working here. Wait, it is working here. Oh, wait, that's so good. Wait, so if it's working here, then I have to understand, is it working here? It is. Oh my god. Wait, it's actually a lot better than I thought it was. So it's actually just for one chunk. Okay, so this one is not working. Huh? Oh. Okay, this one is. This one is not. Okay. Okay, so this one is not working. And this one stops. I actually don't know when it stops. But we have another chunk. Is that the same? It is the same chunk. This one collisions. This one no collisions either. No collisions there. Oh, but we have collisions at the top. Wait, that's weird. Wait. I can't get out. Huh? Wait, what? Wait, I can't get... Oh, okay, I can. Wait, so... Wait, I'm stuck. Oh, no. Oh, no. Ah! That's weird. Collisions are working at most places, but not for this one, it seems. What could the problem be? And it's not a problem of the physics, because it seems to be... I actually don't know, but it seems to be for a whole chunk, right? Not just like a few faces or that kind of thing. Yeah. Let me test again. So this is fine. This one is fine. This one is not fine. Wait, this one is not fine. I thought it was. Oh, this is like a micro chunk. What about this one? This one is working. This one is not. And this one is not. Wait, this one is actually, never mind. This one is working. Wait, it's working now. Was it working before? I don't remember. Wait. Something is wrong, isn't it? I don't remember if it was working or not. But this one is not. I think it's a problem of loading. Like if I try to go there now, is it good? Well, never mind. Okay, if I try to move over there, is it gonna load the chunks that are behind? Like if I go down here. Okay, so I have collisions here. Wait, this is surprising. Well, I mean, I already saw that before. But, okay. And now, collisions. Collisions. Okay, I don't have collisions here. And I do have collisions here. Wait. Oh, this one doesn't. But this one does. Yeah. This one does, this one doesn't. And this one is the modular one. Right? It's like the one that doesn't have the same size as the other chunks. This one has. This one doesn't. Okay. And this one has collisions, yep. So it's something like this. Wait. Yeah. I think. Yeah. So it's basically the -1 something -1. Why would that happen? It's the whole chunk. I might have an idea. Is that the first chunk I'm spawning in? What is the first chunk the player is spawning in? That's not. Let's go to this. Let's go to here. And I'm gonna check it for myself. I'm gonna try getting to a new chunk. Perfect. And now, so I have all of this. And what I wanted to check was the collider and wait, I can actually find back the node. I just realized. From this, if I go to neighbors, I have the -210, neighbors, -110, and wait, -110 only has that for neighbors. So it hasn't been generated in the first place. Why? Is it because of oh, I might have my ID. Oh, I think, is it the same problem? Oh no. Well, no, let's hope it's, no, it shouldn't be. There's no way. Okay, so let's try to go into loader, and I'm gonna go there. Okay. Let's go back over here. Let's go down. So we request a load from 0, 0, 0 to 2. Oh. Okay. And it's loading. Okay. So the neighbor is now. So we get the coordinates. Oh, never mind, this one is fine. Wait, so... Why is this one first? What are the coordinates? 0, 0, 0. What are the coordinates of the player though? Start. So it is considering it to be like 0, 0, 0. But it shouldn't be. I'm not in 0, 0, 0. I'm not supposed to be. I'm supposed to be in minus something. Minus 1, 0, minus 1. Then you go here. And yeah. So minus 1, 1, minus 1. So I have the minus. Yeah, this is good. I divide. Oh, this is wrong. Oh, this is stupid. Oh, right. So it was working for when I was going past the first chunk, but okay. Oh, this is stupid. Okay, here we go. But that doesn't explain why the collisions were not loaded properly. That explains a few things, but not everything. I'm not sure. But it's good. Now we have like better collisions. For sure. Let's continue. Yep. And I'm actually stuck. Wait, I'm actually stuck. Is it because it's finally detecting the collisions? Okay, I managed to get out of it thanks to my speed. Okay. So if I go here, collision, 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 and collision. Finally. It's a perfect victory. That's right. I win. Oh my god. It's finally good. Collision's good everywhere. Oh no, this is perfect. This is so good. I'm so happy. I spent so much time on debugging this. That was so stupid. So many silly problems. But yeah. Okay, and this is I'm so happy. So now collisions should be working like everywhere. Like I can loop as much as I want, go as far as I want, and now if I go down, it's working. This guy looks French, sounds French, and does French activities. I meant French, not friends. Looks friends. Yeah, I French everything. French everything. Baguettes everywhere. And what do you mean by French activities? Is that a French activity? Like, I mean, I guess like for sometimes French, like I think French was the official language for academy peppers like a long time ago, like maybe in like the 80s or something like that. But now it's English, right? But butter. French all the way. Give me some butter on my baguette. Wait. Oh, thanks for the follow, sister. We have collisions. Look at this. How are you? Tell me. Let's talk. But yeah, how are you, Panda 2? How is everything going? It's going like beautifully for me. Because my collisions are working, my custom collisions. Look at this. Look at this. Oh my god. And now I might worry about... Okay, so to do. Let me update what I'm... Well, let me update my notes. So we have a big to-do file. Okay, we do have to do that at some point. But before that, we have finished registering the neighbors of the new node created. So this is done. I mean, I can technically remove it. So generate colliders from chunks, this is done. We want to generate colliders around an observer. So this is done. And now we have to do all of this. But before, or maybe before, I don't know, but we have also to clean. Let's do to do. Clean architecture slash functions. Well, collision slash graph related architecture slash functions. That's one thing. And another thing is, I mean, technically we might want to optimize, but that's not a big deal. Or maybe unload. Unload colliders that are far away. You're very good French skills. Oh no, my very good French skills. Il y a du soleil. I have no idea how you spell French words. Oh, and French pro skills. Ça va très bien. Je m'appelle Fendor, my real name. Trust. Yeah. I trust you completely, Fendor. Il y a du soleil. I mean, it's not bad. It's actually that. You just forgot the spaces. Il y a du soleil. And a lot of people actually, like this sucks to write, right? Actually, French people don't even know how to write this. And they just use this instead. Il y a du soleil. Because why would you have this, right? When you can just have this instead. So yeah, that's what I do. French people are a bit weird, but that's fine. I'm so happy. I'm so happy. Oh my god. Okay, this is finally working. And now, okay, so what do we do? It's already 1 AM. Oh shit, I have work tomorrow. French people are a bit weird. True, true, that's a lot. Thank you. So I don't have to implement this. I don't have to do this, because it's working for some reason. For some reason. I do want to slide and compute the normal and the MTV. Okay. Do I want to split the functions? That's the question. And I was thinking about optimizing the colliders, but gotta go do something. Goodbye. See ya. See you another time. Let's close. This is not a crash. You didn't see anything. Okay. So let's open the editor now. I'm so happy, oh my god. Let's open and let's push everything to Git. I have to decide fast. I feel like I'm losing a lot of time just deciding what I'm going to do next and, you know, just being happy about what I did. Which is good, you know, being happy is good, but you still have to produce things to continue. Something like this, something like this, and then we have the collision loader. Okay. Do we have anything else? Chunk graph. Yep, we have this. This is new. Ah! Boom. We also have... I think this is it. I mean, I should maybe remove those files because every time I'm just checking them, but generation server is nothing. Rendering server is nothing. Collision generator. Wait, this one is... Oh, no, that's nothing. Yeah, you know what? Let's remove those. Or maybe not. I mean, yeah, we're gonna add the files again when we need them. Same for the rendering server. So this is not there anymore. Boom. And same for the generation server. Boom. Okay. And we also have a voxel server for some reason. I just decided to create everything, but I haven't actually used any of those. Okay, so now it's a lot better. Greedy mesher. This is also nothing, so I'm gonna remove it. And voxel collision. Yeah, nothing. Header, C++. Yep. Okay. So here we go. I'm actually going to close this and regenerate the whole solution because it's been a while we haven't done that. Wait. Okay. So that's just going to be a copy and paste. I already had this selected. Perfect. Boom. Okay. Then we go back there. Git status in the meantime. It's gonna take some time. Git commit 3 voxel 34. Chunk graph added. Collisions. Now, well, colliders. Now tiling with space. Well, tiling. Working with negative values, well, negative positions. And I guess that's mainly it. That's not a lot, but there's been a lot of modifications. Okay. And then we have the game. Did we modify the game? Not really, actually. Okay, good. Let's take a look at this, regenerating. Okay, so what are we gonna do? What are we going to do? Reload. Perfect, and we start. We recompile and stuff. So we have the minimum translation vector and normal and collision points to find. Or we can clean the architecture. I think I want this because cleaning the architecture could take like a while. And in the meantime, we could just do something else. Yeah, why clean the architecture when we can do something else? So let's go to the physics server. I'm gonna have to remove that when I was talking about cleaning. So I have test collision against all. Right there. Wait. Right there. And I do a bunch of things. I actually wanted to optimize this too. Instead of like giving directly a new axis group. Well, actually I do want to give only the new... No, I wanted to give like some... I am actually not sure. I'm actually not sure what I want. I think I want two different things. But in this case, I want to give more than just the cross products. I think I want an array that contains all the possibilities. So I'm gonna only look through this array in the end. But I'm gonna curl the axes if they are the same, basically. So like if those normals are the same, then we're going to have each one only one time, right? Instead of having like duplicates with A and B. That would be the idea. That way I would have to loop a bit less. And I would have to axis group. And I would have to project a bit less too. Right? And there was also an optimization about position. Oh, I actually want to do that. Yeah, right. I forgot about that. Maybe that's the thing I want to do in priority. It's allow chunks to share the same shape, but with a different position. This is what I want. Position or rotation. I mean, I guess position is fine for now. And it had to do with this. So I reserve, and I project. So when I project, I do this. And the thing was, if you do vertex plus position, if you project onto the axis, then it's the same as... Oh, I get it. It's the same as at the end, when you have the min and the max. You project the offset. So you do something like offsets dot axis. And what? And you add this to max and min, something like that. Because, wait a second, I have to write some stuff. So let's say you have, let's go there. Oh, actually, yeah, let's write there. So you have a dot product. A dot product is x1 times x2 plus, I'm just gonna copy, plus this with z and y, right? This is it. So now let's say we have instead axis x, well, x axis, y axis, z axis, okay? Now let's say that to your vector, my apologies. Let's say that you want to add an offset. So O, let's say. So we have this plus offset. Well, x offset plus y offset plus z offset, something like this. This is equal to doing do I actually need to do the plus? I mean, yeah, I think it's for the best. So it's basically the same as doing this plus this times x-axis plus y times y-axis. So it's a dot product, right? The offset times the axis. And we instead have well, we can remove this. Right? Like technically it's the same as doing this. Like this is equal to this. So we should be able to just project the shape one time and then add the offset to the minimum and the maximum. I think that's it. What is the offset? Adding the offset dot to the axis. Okay, so that's a nice optimization. That's a great optimization. Let me think about it. So how am I going to do that in practice? Yeah, basically what I mean is this plus equal this and min plus equal this, right? But now we need to find the offset and like we have to store it and have like a good architecture for that. You know, architectures, right? How are we going to have this? So we have the convex shape, but we want to reuse the same objects, right? Convex shape, convex object, I don't know. I mean, it's supposed to be in like a concave shape or something like that. Let me go back. This, get or add projections for a convex shape. The problem is that we only have concave, well, we only have collider, concave, and convex. We want more classes. Yeah, this is crazy. This is a crazy optimization. Yeah, let me actually just ask ChatGPT, SAT, how to optimize it for colliders, well, for multiple colliders that have the same shape but different transform. Because I know this for the position. I just want to think about the rotation because I think there was like something for the rotation, but pre-compute everything in local space. Yep. I know. Transform axes instead of vertices. Yep. Transforms times this. For two objects. Compute this. Inverse TA times TB. Now object A remains completely in local space. But then you still have TB, right? You still have the second B. These vertices using M, or equivalently transforms the axis. Yeah. One space vertices every frame. Wait. Let's go with this. Cache world space rotations. If they move, cache rotation, inverse rotation, and the translation. Instead of rebuilding matrices. Wait. Yeah, I was thinking about this, but you think about it? Try that axis first. Yeah. Use hill climbing. Yeah, I was thinking about doing that too. I mean, I did that in my previous project, but yeah. SIMD projections. I mean, okay. Skip normalized axes. I don't have that. Well, I mean, technically I do, but I'm not normalizing. I don't care. Reuse edge directions. Wait, what? Specialized SAT that never transforms vertices at all. All 15 axes are evaluated using the rotation metric directly. Wait. From the half extents with no per vertex dot products. That's nice. Wait. I'm gonna not that. I'm gonna keep that. Because that might come in good. That might be good. Because I do have cube shapes right now. I do have OBBs. And I think I'm gonna keep those because it's like a bit complicated to like decompose a concave shape into a convex shape, so if all colliders share the same convex mesh, well, not really. Per collider. I think there was something about what about the transformation? Well, tell me more about the transformation of the axis instead of the vertices. Yeah, I know. This is what I was talking about. Well, with a vector, not a matrix, but yeah. Rotation. Yeah, this is the rotation matrix. Wait. Oh. No, this is a bit different. Normally you compute this, yep. Every vertex is multiplied. And yeah, that sucks. Now, move A into its own local space. Yeah, but no, right? Because that means you have two projects. I'm not sure I like that. Wait, do I? I have to think a bit more about that. Cost comparison. Yeah. Relative transforms. For repeated shapes. Shared local vertices. Wait, what? Yeah, I mean, yeah. OBB. Half extents. It's like oriented though. But, okay. By center, orientation, and half extents. Maybe I do want something specialized for OBBs then. Represents each maximal cuboid by this. No vertex transforms. No vertex projections. And it's analytical, right? And only computes dot products between basis vectors and the center of set. I'm not sure about doing this because like my algorithm makes it like pretty flexible, and I'm not sure about like optimization using this because right now I only have like the projection is in like 01 because I just cache it. I just cache the projection, so it's pretty good. That's why like I can just run my game and I can move anywhere. And I mean, even though I have 1000 colliders and I'm testing about all of those colliders all the times, this is going so fast, right? Like I can be here, but okay, just a warning, I might crash. But let's connect. And we have this, I'm testing collisions. Now I'm gonna stop, wait, that's not, oh, that's the wrong one. Boom. Okay, here we go. I run. And this is pretty fast. And I'm gonna stop. Gonna close. Okay, I haven't crashed yet. Perfect. I did remove a lot of things to profile. I still have 20 gigabytes, so that's good. Okay, so when you look at this, I have, I don't even know where I'm moving. Generate cube chunk. But I have the threads generation loop. This is not really what I want. What I'm looking for, I mean. Test collision against all. This is it. And this lasts 3 milliseconds. And how many? I actually don't know how many I have. I mean, I do have my... Oh, no, never mind. The renderer is not gonna tell me anything. Okay, I guess I can't see the amount. But I'm sure this is a lot. Believe me. I mean, I should be able to see it pretty easily. Debug lines. Ready. Do I just want to... I don't know. I'm just gonna... Maybe in process. In process I can... draw. I can just do this. and colliders count. So I'm gonna have NB convex shapes, NB total convex shapes equals 0. And I'm gonna do a plus equal. And then I'm gonna print. I should like register it. Register it, but I forgot how to do that. But anyways, so right now we have, what the fuck? That many shapes. And when I move, I still have that many shapes. But how is that possible? Did I just generate everything possible? Oh no, it's not going down. Okay, here we go. So, yeah, we have a lot of shapes, and they're not even curled. We're just testing against everything. And it's just like really fast still, right? So that's what gives me hope about having a giant turtle into my world. Even though I guess most shapes are static, right? So it's like very fast. I don't have to do a lot for that. Yeah. Yeah. Okay. So, woo! Wait, what was that? I just went inside something. No? Did I? Or is it because I'm just so fast? Maybe I was just too fast. But yeah, I still have like a lot of how many FPS? 30, okay. Well, I mean it's fixed, right? So this is like really good. I have so many colliders and this is still so good. I mean, that's great, but let's stop being too happy about that. I need to update this. I need to improve my thing. And I did want to ask ChatGPT something. Because I think its reasoning is a bit wrong. If you rotate the axis, doesn't that mean, well, to compute in the local space of shape A, doesn't that mean you always have to project the other shape into that, well, onto that new axis? Yep. Yeah. So I mean, you can basically prevent recomputing things for A, but not for B. Real optimization. Transform the axis instead of the vertices. When the projection algorithm doesn't iterate every vertex. I mean, yeah. For SAT with vertex projection. Okay. Yeah, I should do that, but but that's fine. But no. Let me think about it. I have to think about it. How could I call this? Convex object. Concave. I mean, it's supposed to be concave. I'm not sure. Well, concave. I mean, concave is kind of shitty, really. Like, it's a group of convex shapes, really. Maybe I can just call it, like, object or something. I don't know. Because I'm never going to actually collide concave shapes. Voxel collider. I can share the same shape, potentially. Technically, I could. Test collisions. Colliders. Voxel collider. Yeah, technically what I want, I think, is I don't know. Help. I just know that concave shape is kind of useless. I just like used to optimize things a little bit, I guess, but it's not necessary. Convex shapes. It's just a group of like it's a convex shape batch or something. And then we have, let's have a position here. Position. But if I do that, that means I need to wait, axis group. I do have the projections there. So maybe I do want other projections. Let me just confirm something. So if you only move the position, can you not just add, well, can you just add the offset? Can you just instead add the dot product of the position and the axis to the min and max instead of moving the vertices? Or do you even need to? Yeah. Yeah. You can do this. That's what I was thinking about. Yeah. This. Even better. You don't even have to add the offset inside the loop. I mean, yeah, that's... What? What? I know. Only one extra dot product per object per axis. Yeah, I know. I don't get it. I mean, it was the same as this. With rotation, it doesn't work. Yep. Full optimization. This rotates the axis into local space. I don't want that. I don't think I'm gonna handle rotations because that sucks. Okay. So I have a list of convex shapes, but then I guess we have like convex 120. This is nice. I like this. But it's not really useful, but yeah. And the position there, do I really want that? No, not here. I think it's fine if I remove the idea of the concave shape. Convex shape, convex object, convex patch. Maybe I could do the same thing as I'm doing with the vertices. And have the projections there instead. Oh, the AI arena works brilliantly. Oh, that's nice. Well done. Projections. Technically, yeah, I could just remove the concave shape. The concave shape is actually not used for anything, really. Is it? Create. Well, that's the example, right? But bind. Get convex shapes. Vertices range. Update. Yeah, it's actually not used for anything. Is it? Well, I mean, okay, maybe a little actually. No. If I share the same concave shape instead of the same convex shapes, is it changing anything for me? Finally, no more tiresome fine-tuning and searching for small bugs. Just creating the mechanics and throw AI at it. That's nice. Do you have anything to show, like on Discord or, you know? You know what? I'm wondering about the architecture, but I can just ask class-wise, what is the usual architecture of a physics engine? Immutable geometry, shared, and mutable instances. Yeah, that's what I was thinking about. So, broad phase, narrow phase, yep. Contact manager, solver. The shape's immutable. So we can't change them. And it's shared. Yep, by many colliders. And I guess it can be a box, it can be a sphere. I guess. All points to the same box shape. Yep. Collider. This is an instance. On one or more colliders. Wait, body. Oh, it has one or more colliders, not shapes. Wait, it only has one shape. A collider only has one shape. Broad phase, narrow phase, contact generation, solver, cached collision algorithm. Between two colliders. Yeah, I did want something like that. For now, I just have that for axis, but yeah. Shape-specific helpers. What I was thinking about is if shape inherits, well, uses inheritance and virtual calls to be slow. And another thing is, I actually don't know. Yeah, how to test each shape against each other in an optimized way, I guess. No, still just words and numbers. Avoid virtual dispatch. Yeah. That was my question. Type enum plus dispatch table. Oh, I guess. Oh, that makes sense. I guess you can have that. Well, I mean, I guess it's possible. Double dispatch. I did that with my previous engine, but that sucked. It separates the shapes. Support. What I would do for your engine, I don't care. Even faster. I can skip. Yeah, I know that I can do that. I know that I can do that, but no, still just words and numbers. Yeah, I think I've read that before, but okay, I see. I mean, still nice, GG. So, collider. Let's have a position. And let's remove all of this. Because I think we don't need this. We don't need the concave shape. Actually, if we have different... Wait. Oh, never mind. No, never mind. No, okay, no, this is fine. Because we need the same vertices. No. Yeah, maybe just rename it then into convex shapes batch. And but the position, what about the position? Where should I put the position? Because it's gonna impact stuff, right? Because if I have the position here, that means that my projections should be there. I don't really like that. but well. Maybe that's what I should do. And we have projections that are going to be projections. Wait. Axes to projections. Do I need like another hash map or something? Can I do axis to projections? I mean, I guess I'm still gonna have this, but wait a second. I remember I had variables named pressed, ons, and moving. Attraction, what do you think? Pressed, ons, and moving? What do you mean? Pressed, ons, and moving. I don't think you should have both, like two different. Like the pressed ons, I don't know what it is. Like, and moving, I would call it has started moving, something like that. Like the pressed ons is really about, like pressed ons is about the input, and the moving is about the movement. It's like two completely different things. And I think, you know, you need it to be about one ID specifically. I think I understand what it is about, but yeah, like something like has started moving is like a lot more explicit to me. Just pressed. Oh, just pressed ons and moving. Yeah, I mean, has started moving, right? Or like is moving is fine too, I suppose. Access to projections. So let me think about it a bit more. So projections are local projections. Local projections. Well, projections to axes without delta position, right? And then text didn't send for some reason. Oh. Okay. That's weird. Maybe it got detected like maybe it got detected as a spam or something. I don't know. Hey, how are you doing? I'm good, what about you? Yeah, Martel. Welcome, welcome. And those ones are projections with position offset. Maybe. Safe span. Access to projection. Let me think about this. I mean, technically, if I have the index of the... I don't know, actually. The rate is pressed. The rate is pressed and directed is not 0. That's what that variable abstracts. But I was thinking the same thing. I don't think you should... I mean, it depends on like the context and stuff, but I think the... Like what you're trying to do is kind of wrong in a logical sense. Is that you have a is pressed, but it should be a is moving. I mean, I would have to see more of the code, but yeah. Or like you can have is forward pressed. Well. Is moving forward. Yeah, okay, I mean, I think I see kind of what you want to say. Like, you want to know when the player is moving and it's not due to an external force, something like that. But, I don't know. I don't know. Projections with position offset. Should have a boolean done with an if statement. Huh. Yeah. I see. What I did is an anti-pattern. Okay. I mean, I don't know. I don't know if I would... I don't know. Yeah, maybe something like this. I don't know. I mean, it makes me want to put projections in here now. And the concave shape would really be kind of like not useful. No, I still have the vertices actually. I mean, they're kind of useful, I guess. Yeah. Okay, let's skip this. Wait. Okay. So yeah, that should be fine actually. That's probably fine. So now that we have these projections, access to projections with position offset, maybe. I mean, I think something is wrong because I'm not even detecting when an axis group is like changing. Or maybe I guess it could be a new axis group. I could just make a new one, but then what about removing it? It's dirty, maybe? Maybe I can just check when it's dirty. This is dirty, technically. I don't know, should I? I don't know. Maybe I need a callback. Good for recycling. Maybe. I mean, you know, the compiler. I mean, I don't know about GScript, but I mean, basically in a scripting language, like it's a scripting language, it's not supposed to be about optimization, but about speed of writing, speed of development. So you don't have to optimize things that much, as long as it's like readability is like the better thing to have. And if you're writing in like C++ or that kind of thing, then you can count on the compiler to optimize things. If it's like in the same C++ file or that kind of stuff. So I would say don't think about it too much. It's good to prevent repeating the same things, but if you try to abstract and like do that kind of optimization and reuse the same variables when they don't actually match completely logically wise, then that might not be what you want. You might just be losing your time. I have to think about when it's getting dirty. So when this is getting dirty. So what can get dirty? That's the question. Axis group can get dirty. What else? So axis group is basically the well, axis. Well, that's an abstraction. That's the problem. That was just bad code. Okay. You should say so. Okay, let me go to my documents. So problem. I want objects, but I want some data to become invalidated, dirty, and I want things to recompute on demand when needed. That's my problem. How do I solve that? And then my other problem is I want to cache projections made with position asset. So for the first one, what can I do? Because I think it's like kind of important. Position, projections. So I have my different classes. And I also want to cache computations computed. I want to cache data computed when checking the collision between two objects. And what I mean by that is I want to cache the axis, the separating axis. So I need to look at my diagram again. So I have all of this. Yeah, that helped me at first, but I still have a problem. So let's think about things again. Let's have like this. Maybe not. Okay. So we have a convex shape. I need to, basically right now I'm building things from bottom to top with like the low level objects, and I was like close to the algorithm and stuff, right? But I need to build from top to bottom. So let's say we have, but for certain states we can do jumping and moving and mix the booleans. Okay. So let's say I have one collider. Oh. So this is a collider. Or like, let me remove. We have one collider. And I have another collider. And we want to check collision. Well, check if colliders collide, right? Like check collision. So we have that as inputs, right? Let me change to straight line. Maybe not. Wait, actually, can I? Yeah. Okay, so here we go. So we check collision. What is this doing? Sorry, my messages get deleted by accident. Okay. That's fine. So I check collision. And this is loop for every convex shape. Loop. Well, it's not actually what I want. It's actually not the top level I want. It's 2 AM. Okay, yeah, we have to. I want to write, like, to at least, I want to at least have a plan on how to do things. So in the end, what I want, do I actually want, let me think about things. So physics engines usually have a solver step. Is that needed? I mean, it is needed, but is that needed if I have no rigid bodies? But only like, I mean, technically it is needed, right? But maybe not, I guess. Yeah. I mean, it depends. But that means that the order, it depends on the order though. Well, I mean, yeah, that's fine. Multiple contact points. Even without rigid bodies, a small solver can help you if you have multiple simultaneous contact. Yeah, I know. Like if you slide and stuff, right? Too. I do want a solver. Sliding. Yeah, that's what I was thinking about. Complete the MTV, move out of penetration. Remove only the velocity that has been... No. And then I slide. But if I continue to slide, I might... Wait. Technically, yeah. But that's when you, like for sliding, you actually want like this kind of solver though. Broad, narrow, contact generator, and resolver. So this one is at the top. Wait, no, never mind. Sorting contact points. Wait, what? It's not a function call. Move the character out of penetration, updating velocity for sliding, stepping over small obstacles if your game supports it. Yeah. But let me think about things. So let's do... Basically what we want is a move and slide, right? We want to move and slide potentially. So if we want to move and slide with a collider. Oh. Not really. It's Okay, let's change things. Let's change things. So we have objects that don't move and objects that move. We have static objects and we have dynamic objects. Okay. Those objects have a collider. But those ones have a velocity. Right. Okay. And like maybe the collider is going to have well, it's gonna have stuff, okay? Could be simplified by direction and okay. Okay, so we have this. Now what we want is we want to register objects to physics system. In any case, we want this, okay? And then we have physics system step that is going to update position of dynamic objects. And I mean, we have the velocity, but also the angular velocity, maybe. Like the linear velocity and the angular velocity. We have both. Maybe. Potentially. Have a good night. Have a good night. Bye-bye. Sleep well. So what are we going to have in this? We are going to have a solver that's going to loop multiple times. Loop multiple times to resolve constraints. To solve constraints. I don't remember how you do that well though. But okay. Then we have... Wait. Physics solver algorithm. Math starting Then you have equations. And run the math. Common algorithm types. Use for objects in simple motion. Solvers use numerical methods like this. I used this one. I've implemented this one. Calculate the future path of a moving object, step by step. Use for solid objects that hit each other. Solvers calculate how much force is needed to stop objects from passing through each other, commonly using fast iterative solvers like Verlet integration or constrained optimization loops. And this one. I mean, I think I want this. Let me... Rigid body dynamic solver. Math for rotation and solvers for collisions and joints. Advanced. Extended position-based dynamics. What? Calculate forces and convert them to speed. Adjust positions and orientations directly. Okay. Iterative. I do want that. Impulse based. Let me just have. I just want some code, some example. Wait, can I? Video game implementing position based. An introduction. Solver 2D. Okay, I just want that. Okay, this is it. So apply forces. Update positions and velocities. Detect collisions. Wait, do I want to update the positions and velocities, really? Detect collisions, solve constraints, display results. I don't want to update them straight away, right? Solve a 2D. Oh, this looks really good, but it's for 2D, but it looks really good. Relaxation, self constraints. I think this is like really important. So I want to look at this a little. In Tomb Raider we used. Oh my god. Okay. Whoa. What about this? Oh. Wait, that's the same one though. Okay. Forbidden. Okay. Particle simulation. Rigid body physics simulation. So what does this look like? Oh. So we have this, we move. I mean, this is... well, I don't really care about that, I care about collisions. It's just the part 1. Oh, I hate that. Part 2, part 3. So collision detection for solid objects. And constrained rigid body simulation. So I want that. I'm just gonna look at this, but I think it's basically just the SAT, right? Narrow phase. Yeah, okay, I don't really care about that. I already implemented that. GJK. Yeah. Continuous collision detection, resolving collisions. Okay. Yeah. Part 1, and now we have only described unconstrained simulations. Yay! Apply constraints, joints, and non-penetrative constraints. Wait, is that really what I'm not sure about that. Optimizations. I don't know. I mean, this is like the... This is the one thing I want, though. The following diagram shows a high-level overview of the general procedure of a physics engine. But... Compute force. Total simulation time. compute force, we move, but there's no collision. Okay. You know what we're gonna do, right? It's not this window, it's this one. So, physics solver. Tell me about the different steps. Like, list me about the different steps. Apply forces, so you do this. Nothing moves yet. Yeah, it's okay, okay. Oh, by apply forces, it's like, okay, put the forces into this thing. Okay, I get it now. Yeah, I was thinking it was wrong to like apply the forces like by adding. Acceleration is computed from the forces. Now they have predicted acceleration, well, velocity. No positions change yet. Broad phase. We have a bunch of things. Narrow phase. Exact collision algorithms. Contact. Movement. Contact manifold generation. Reduce them to a stable set. Instead of storing 40 contact points, reduce them. A box resting on the floor might geometrically have dozens of touching features, but the manifold keeps only a few representative contact points, up to 4 in 3D. Right. Oh, wait, I kind of get it. Okay. This improves stability. Yep. Constraint generation. So... everything becomes a constraint. Contact becomes distance is higher than 0. A hinge joint becomes this. And a spring becomes this. Yeah. Constraint solver. Suppose two boxes overlap. SAT tells you normal penetration, so you can compute the minimum translation vector, I know. So that they separate, momentum is conserved, and use an iterative method. Yeah, that was the goal. Usually 4 to 20 iterations. Position correction. Even after impulses, small penetrations remain because the solver is iterative. Yeah. Position correction. This. This removes tiny overlaps without injecting excessive energy. Then we integrate the positions. Okay, yeah, we just move. ABB's change. Broad phase updates is 3 grid. Why is the solver iterative? Yeah, I mean, I guess. Yeah. So wait, a solver. How is it coding solver? Yeah, it's a solver. So this. Okay, so we have basically in the solver we want to. Do we want to broad face every time? So broad phase. Let's say we have broad phase. Then we have the narrow phase. So that's like the SAT. Then we have compute how hit points at the point of collision and stuff, and the minimum translation vector and stuff. Actually, first we need to compute forces applied to each object. And I mean, I guess then we loop. Right? Integrate velocities. Well, I mean, compute forces. Okay, I guess we have compute acceleration and velocity. Compute hit points. Slash generate constraints, I guess. But I mean, I guess it's two separate things, right? Because we have hit points, but that's like one constraint amongst others. But that's fine. That's fine for now. Well. Generate constraints from hits too. And then we have the constraint solver. Constraints solver. And then we, well, constraint solver, then we have position correction, I guess. And we update, well, due to constraints not being solved entirely. Then we have the, well, updates positions, basically. And I guess that's mainly it. These are mainly the different phases to go through. That's a lot. I actually want to do all of that. Maybe not. Because I still have to make a game, right? But yeah. Maybe it's some very simple thing. Compute forces. Access to projections. I want to remake my physics server, really. I really want to remake it. But basically, let's say we're gonna have a step. Okay. We're gonna have a step that is gonna be here. Instead, we have... So we have all of that. Compute forces applied to each object. So we have compute forces. Compute acceleration and velocity. Technically, it's kind of... We can do that in the same function, but that's fine. So we have the broad phase. Wait. So like for each dynamic object. For each dynamic object it is. So for dynamic objects in dynamic objects, we can say. For all of those, do we actually just want to generate... I was gonna say collision pairs, no? Like, I mean, the broad phase, what is the broad phase supposed to do? Am I supposed to loop, or am I supposed to call that and receive, like, pairs? Or, like, objects in the same, like, close to each other? Pairs would be clean, but yeah. Optimization-wise, broad phase... Should I call the narrow phase in the broad phase? Or should I have the broad phase return something like pairs of colliders that can collide? Keep them separate, yeah. Yeah. That would be the best. So... Easy multi-threading, yeah, I mean, okay. Easy filtering. Persistent per cache. One exception. If your broad phase is query specific. So optionally continuing to the narrow phase internally. Yeah. I mean, yeah, that makes sense. Okay. So... the broad phase. And yeah, I want to know... should the broad phase be sampled from objects? I mean, it depends on like the data structure, right? And like the algorithm and stuff, I feel like. So I'm not sure about that. From dynamic, well, from objects that are moving, or should it just return pairs? Let's say. Your update is proxy. Yeah, I know. And yeah, the query is like different. Yeah. Yeah, okay. That's what I was thinking about. So you don't want to recompute all possible pairs. So I want to query for dynamic objects specifically. Find overlapping AABBs, emit pairs. So dynamic AABB trees. And Broadface around queries. Yeah, I know. Well, not really. Well, it depends. Basically, I don't want to... Well, it depends. It depends. Your physics step becomes this. Query and... I mean, I guess I could put a callback in there. That's a good idea. But yeah. But yeah, I'm gonna have a lot of static objects. And what? Let me think. And I don't want to test for all of them. So what should I do? What should I do? Maybe just get dynamic object pairs. Like, get dynamic... Well, it's a broad face, right? Broad face that gets dynamic object potential collision pairs. So then we have a pair of like a dynamic object and another object, like a collider. Dynamic collider with a collider, right? Collision pairs. Okay. So then we have well, I guess it should be some kind of... Yeah, instead of creating pairs. I'm not sure about that. Okay, so the problem is that if I loop and have a callback, then what happens if I have two dynamic objects? I want the pair to only be there like one time. So I think that's like the way to do things. Or do I need... I mean, maybe I can... Well, it's not just a pair, it's a vector. It's gonna be a local vector. Like this. Like collision pair, maybe? Collision pair... I don't know. Like something like this. Okay. I mean, gets potential collision pairs, I guess, is what I really want. I'm also wondering about like vehicles and stuff. I guess they're gonna be dynamic. Over. Hmm. Let me... I think it's not really about static and dynamic, it's about objects that are not in the same object, that are not moving the same way. So we can have like a bits mask or something like that for those. But if we have a lot of objects, then it's gonna be a bit difficult. 32. No, we're gonna have more than 32 objects. Well, I mean, we can have a pointer towards subjects and okay. Yeah, it's just gonna be collider. So then we have the collision pairs, I suppose. So what should we do next? Make graph. Good. Broad phase, narrow phase. So for collision pair in this, we loop. And we do the narrow phase with the pair. And potentially we can optimize this, right? Because we can have some cache with this. So then we compute the hit points, MTV, and that kind of stuff. So we might have narrow phase with like narrow phase results, I guess. So then we generate the constraints. So narrow phase constraint, I don't know. Get constraints. Then we solve. Maybe something like local vector constraints. Not really, but maybe that kind of thing. So we generate. I mean, technically, like pseudocode, you can have this. Then you can solve them. Then we can correct the position. And update positions. I guess that would be how the loop should look like, ideally. Ideally. Yeah, it's okay, it's already 2.5. Collision pairs. I mean, right now I basically have test all, test collision against all, right? Let me think about it, because I have a lot of chunks, but they're part of the same space, and they're supposed to move along, basically. So they're not, I'm not supposed to test collisions for those. And it's not about being static or dynamic, because if I have like a plane, a giant plane, then like the different blocks of the planes are not going to collide with each other, right? That makes sense. So I need something for that. I need something about that. Maybe instead of axis group, I want like a space. I think I want some kind of space. And if the space is the same, then I'm not gonna... Well, maybe I want both actually. I want both. Yeah. And I want additional axes. So I'm in collision pairs. Let me get this again. So basically this is it, right? That's collision against all, well, not really. I think. And yeah, it's not about the static and the dynamic. Like this is actually, it's not even being used, right? So I mean, I do have tests, collision against all. I do have this, but yeah, I'm not using. Let's remove this. This is stupid. Collider movement type. Yeah, I think it is kind of stupid. Destroy collider. What? Destroy? Am I even using that anywhere? Yeah, I'm not. Remove swap. Register. I'm gonna remove. Find enum constant. Removed. Removed. And this is it. And instead I want... What do I want? Hello, Succeed. Yeah, I actually have... Look at this. I actually have collisions everywhere. Like, no matter where I go, I have... Well, I have too many collisions, as you can see. Yeah! Okay. Yeah, collisions there, collisions there, collisions there, collisions there, there. Collisions here. Collisions there. Collisions everywhere, man. It's working well. It's a success, repeat. Boom. Very nice, yeah, it is for sure. It took me a lot of debugging. It was like very silly problems too. I do have to clean my architecture a lot, and I do have to improve my physics system a little bit to like slide, for example, because right now I just get stuck when I'm against a face. But yeah, we did support this. About this GPU. What do you mean this? Oh, DLSS. DLSS. I mean, that's like for the rendering, right? I mean, I'm not planning to do anything about that. I'm not planning to do anything about that, but I know it's like some very abstract thing that you can use like on a lot of games, right? You just need the frame, I think, so... Maybe you can use it. Oh. Wait, what was that? I think I've been... Yeah, okay, I moved too fast, that's why. If I go there. Ah! Nope, that seems to be good. Yeah. But yeah. And right now I'm trying to make my objects slide, you can say. But that's a bit complicated. To compute forces, maybe I'm going to have a list of objects that moved, so objects that moved. Well, moving objects. Or like spaces, maybe. Yeah, spaces is maybe for the best. Well, collision space. Then... Then what? Then I'm not sure. I compute the forces applied on each object. Should I? Wait 2 seconds. How to compute forces applied on a big concave object. Static concave object does not receive forces. Dynamic concave objects treated as one rigid body. Yeah, that's what I mean. So we have stuff. We compute the torque. Where C is the center of mass. Yeah, my question is about the center of mass. Is it safe? Or breakable? Yeah. Yeah. That propagates through the structure. Finite elements, mass spring systems, constraint graphs. Yeah! They don't. Yeah, they have convex ones. Maximal cuboids. Wait. Convex decomposition. Okay. Consists of maximal cuboids. Each cuboid can generate contacts independently. Force and torque. Yeah. So I'm not using impulses. Wait. I'm not sure about all of that. I mean, technically, I guess. I think I'm gonna have to make my own system about that, because I don't want the complexity and the slowness of the usual solver thing. Of usual solvers. Moving spaces. Okay. So maybe I want something like this. Compute forces for those. Compute acceleration and velocity. Seems good. Yeah, seems good to me. It makes me think a lot about creating Minecraft. Create aeronautics is like a mod. So I'm thinking a lot about the visuals, like how it is in that mod. Like you have a map and you have like arrows for forces and stuff, and yeah, you completely have this. This one I'm sure about, I guess. Then we have collision pairs, I guess. Narrow phase get constraints. Yeah, so we basically, what I wanted to do is, but I mean, am I going to do that? Like, technically, I can just not do that, I guess. The thing is, for the player, for example, we need custom physics, right? So I guess that's why usually it's not in a physics system. But yeah. I'm not sure much about the constraints, but I mean, kind of, I guess. Correct positions. I mean, this seems alright. This seems alright. This seems alright to me. So we have this equals something. I'm going to have maybe this here with collision space. Well, it's basically going to be an object, a collider. So we have this, we have the position, and it has a list of colliders, I guess. So local vector of voxel collider, something like that, right? Then we have a list of moving spaces, for example. So compute forces. Well, I mean, I guess we're gonna have position, like the, I mean, we want the forces, right? So I guess that's gonna be compute forces. We're gonna have compute gravity. Oh, so we are finally going to have gravity, right? I forgot about that. I guess we do need gravity. So gravity, moving spaces, do something like this. Not really though. I mean more like for this space in moving spaces. Then we have compute gravity, for example. And okay, simulated, I guess. Simulated space. It's not moving, it's like simulated. Oh yeah, I guess it's like could be different maybe. That's fine. Simulated spaces. Okay, just tapped. Space. Boom. And we basically have something like simulated space dot, well, this, not position, but let's have the acceleration. Like maybe forces. Because the acceleration is forces, well, sum of forces equals NA, right? So the acceleration is the sum of the forces divided by the mass. So that means we're also going to have a mass. We are going to have the acceleration. We are going to have the position, I guess. And we are going to have maybe a rotation. So how can I call that? Quaternion rotation, potentially. I mean, yeah, I want a rotation for this. Acceleration. We have forces. And I guess that's basically it. So compute gravity, we have the force of the gravity. Is like plus equal. Let's do this equals 0. Well, vector 3, 0, or this. Yeah. Then we plus equal g times m, right? So the gravity is like the mass of the... What if I want different planets? Like different kind of gravities and stuff? I mean, for now, I'm not gonna care about that. Simulated space. Mass. And we have G that is it like 9.87 or is it like 6 dot something? So gravity at the surface of Earth. It's 9.8. Compute gravity of objects. mg is 981. And this is this, right? Divided by the radius squared. Do I want that? Mass of the Earth. It feels a bit too much to have it as a float. I'm not sure about like float precision if I have it, but well, gravitational constant. Because there's going to be the division anyways. You know what, I'm just gonna keep 9.81 and have custom gravity with other shapes. Okay. So by default we have... shit. Have custom gravity with other shapes. Then we have G equal 9.81, like planet's gravity. We have this, V++, it's 0 minus, like that, and 0. What time? 3 AM, okay. So we have this, we compute. Then we compute. I mean, technically we should have probably an array. Maybe not. Let's do this. So we are gonna have the simulated things. We are gonna do... For each space, we're gonna have the acceleration equals the forces divided by the mass, right? I guess that's it. So I can compute it directly in the same loop, technically, but I'm gonna keep this for now. Then I want to get the potential collisions and stuff. I mean... I'm not sure about that. And collision pair is actually... I guess we want different things. Lol, an AI agent reads another AI agent's logs and learns from it. Increase the score by 300%. Incredible. That's nice. Maybe I want different kinds of broad faces, really. I think I want a broad face for like different space objects. And then... Yeah. So... Basically something like this. Well... Space collision pair, maybe. And space broad face. So we are first going to have broad face among different... Well, between different spaces. Equal big, well, it's a list of chunks that move, like a space equal list of chunks that moves the same, right? That moves the same, yeah. So this is basically going to reduce some collisions. I shouldn't have like a lot of things there. Like basically there should be almost like nothing. Right now there would be like only one pair between the player and the actual planets, right? And then after that what? I can probably optimize things in this way. I can like return every chunk that's going to collide. So we have colliders. So list of colliders. Or convex shapes, maybe? Maybe, yeah, a list of convex shapes that can collide. Between two spaces. I think that's for the best. So convex shape, broad face, kind of. We have for each collision pair. So for collision pair in this. Something like that. Or like, it's basically gonna be a broad face where both objects, I mean, can be chunks, but not necessarily though. Still I did, I see, yeah. Probably gonna stop soon, since it's like 3 AM. Broad face where both objects are. I'm trying to get an architecture of how the physics system is supposed to work. With like the sliding and the gravity and that kind of stuff. When do you sleep, bro? I mean, probably soon. You know, just a bit more. How much do you sleep? I hope a French amount. And not the Japanese. I mean, it depends. Like at that point, I'm gonna sleep a bit less than 8 hours, I guess. Objects on. I'm not sure about that. Ah, that's okay. Nihonjin sleep like 5 to 6 hours, and that's way too little. I mean, maybe. I mean, it depends. I do that sometimes, but let me take a look. Oh, 400. Why in minutes? And whoa, yeah, that's 352. I'm not Japanese, so I can't do math. Yeah, that's like 6 hours. That's crazy. And France is like 100 more. 434. It's like 7 hours? Wait, that's crazy. That's like so little. That's like average. I mean, I always try to like sleep between, well, I mean, to me, like a normal sleep is like 8 or 9 hours. Like below 8 is too little to me. So like knowing that the average everywhere is like less than that, that's crazy. I mean, I guess it makes kind of sense, but Netherlands. Wait, Netherlands. Where else in Netherlands? Wait. Oh, 444. Yeah, okay. According to stats, yeah. All high-Q countries like Finland and New Zealand have the highest sleep. Yeah. That makes sense. I do think sleep is important. Problem spaces are not necessarily cubes, but we can optimize things this way a little. I don't know how I'm going to have non-Euclidean collisions. That's the only thing I'm thinking about. But well. I don't know. I really don't know. Actually, yeah, I have no idea. The goal is to retrieve those chunks, then I mean, do we really want to retrieve the chunks actually? I'm hella smart then. Because technically in my physics system I'm not supposed to have chunks even. Yeah, I'm not supposed to have all of that. The goal is to have an abstraction. But in the case of my cube chunks, then I have a grid, so I can optimize things with that. So basically, grid plus what? Plus AABB's test, I guess. Using cube chunk. In the future. To do. Okay, one day I'm gonna have that one day. But not now. Not now, baby. So then we have the... Well, let's say we're gonna have this space collision pair. So this is basically just returns objects that are on the planets, right? On the same planets, basically. So it's very simple. We have space collision pairs. Boom, boom. We can have add range, right? Like I don't care about the name. We can have that. Then we have this collision pair that is gonna be... Wait, this is collision pair. And this is a convex shape with another convex shape. So we have this, we test each convex shape. Wait, I forgot about the narrow phase. Where's the narrow phase? Oh, never mind. Yeah, get constraints. Oh, yeah, I forgot about that. So, yeah, I mean, I have the convex shape, so I can just do the SAT on that, right? Not a big deal. SAT. Then I have a constraint. Let me actually GPT that. What is a constraint supposed to look like? Right. Without the S. So good for learning. Modern engines. Much more abstract. Linear B, angular B. Is the Jacobian. Why Jacobian supposed to the two boxes collide? No. Instead, push this box. It doesn't think that. It thinks apply an impulse lambda along this constraint, along the Jacobian. H body's velocity. Oh. Y effective mass. How difficult it is to move these two bodies along these constraints. Oh, it's too complicated. Yeah, it's basically the same thing. No virtual dispatch, no. But yeah, okay, it's basically stuff. It's basically stuff. Narrow phase get constraints. So I'm gonna have constraint. Okay. I guess that's it. So local vector of constraints. We're gonna stay. Then we are going to... I mean, technically I just want to push back there. Instead of doing this thing. Like this. It's an out. Right. Okay. Then we generate the constraints. Well. Well, yeah. I mean, we generate with like the springs and that kind of stuff, right? But that we don't really modify things necessarily at all. So let's just have an out. I guess it's like for each space. So yeah, wait a second. Pair. Yes, the constraints were basically added to the parents though. Because even like if I have the shape, I want to apply it to the parent. Adds constraints to parent face. So we have this, solve constraints. So this is basically moving the things apart. Like preventing the player from getting inside the cube, right? So like applying the minimum translation vector, I guess. Kind of. Then correct positions, just some more thing, I guess. Okay. And then the update positions. I mean, update positions is simple. It's basically gonna be in simulated spaces. Is it? Maybe something like that. We have update positions. Simulated. I loop around. And I basically have position plus equal. So normally we're supposed to use Verlet, the Verlet thing, right? But I don't care. Wait. I don't have the velocity. Huh? Wait a second. Am I supposed to have the velocity? I'm not sure about that. Target position, maybe. Like, well, not really. It's like, let's say velocity. Compute acceleration and velocity. In that case, maybe velocity. Then we have velocity plus equal. Plus equal? Yeah, because I guess we are supposed to have some velocity by default, right? Wait a second. I'm not sure about that. Well, I mean, I guess this is it. The times delta. So using Verlet, ideally, we are gonna have the delta boom, delta. We have the delta. No, not there. Here. Correct positions. Not really. Self-constraints, and I mean, yeah, I'm basically going to have to do all of that next time, kind of, but that's basically it. And implement what a collision space is, all of that. Yeah, I was thinking that physics was like finished, kind of, but I still do have a lot to do. And technically I don't really need to do that, but yeah. Do I actually want to do that? Because I can just get... What I can do is just I can get the SAT and compute the tangent and like the normal and that kind of stuff. And try to see if it slides or not. And then I can have like some gravity. And like some very basic gravity, like some scripted gravity. I don't really need all of this. So... Maybe I'm gonna implement this like only when I need like vehicles and stuff, right? Because I have a game to do. I have a game to do. So to do finish implementation when I actually want vehicles etc. For now, just studying the player with basic, well, just scripted player sliding plus gravity is enough, I guess. So yeah, let's just not, because when I'm gonna have my vehicles, I'm gonna have other problems, right? So let's not overcomplicate let's not overcomplicate things for now. And that's gonna be it for tonight. That's it. We just finished. That's it. Thank you a lot. Wait. So who's that guy? Someone told me about him earlier. So I'm gonna do. Let's do that. I don't really know what he's doing, but lead code review. I mean, we can check this. Seems to be nice. Okay, thanks a lot again for watching, and next time let's try to compute the normal and the MTV minimal translation vector from the SAT, the separating axis theorem algorithm that's detecting collisions between our convex shapes. So we can have a player that falls down due to gravity and that slides. That's not being stopped every time. No, bye bye, GG. Thank you. And PP, what? And what else? Yeah, thank you. See ya, and what else do I need to do? I mean, I guess then maybe we're going to actually implement a game. That could be nice. So yeah, ambient occlusion is nice too. But yeah, see you next time. Peace. Ooh.